Hello everyone, welcome to Gate Academy Global. So before starting today's session, I would like to have the input as well as the concurrence regarding the quality of video as well as audio. If both had been perfect, just write perfect over the live chat. And I would also request to each one of you to share this particular link of the session to max of the Telegram as well as the WhatsApp group, so that we would be able to enjoy all of the questions which had been experienced by the electronics people. Is that part clear? So at very beginning, let me focus over the bifurcation of the questions. From which particular subject, how many number of questions are being experienced? From the network side, the total 6 number of questions are being experienced. Probably this must be visible to all of us. Total 6 number of questions are being experienced from the network theory side. 3 number of questions were from the signal system, which has been obviously very small in number. From the electronic devices, the 8 number of questions are being experienced. Probably you must have seen that. From the analog circuit, the standard 6 number of questions are being experienced. From the digital circuit also, in standard the 6 number of questions used to come. Here also the 6 number of questions were experienced. From the control system side, the 5 number of questions will come in your examination. In communication, again, the huge number of questions are being experienced by the electronics people, and that had been total 8 number of questions. Here in electromagnetics, only 3 number of questions had come, and out of 3 number of question, even I can say 1 question was based on the concept of closed line integration, or I would say that had been the problem based on the concept of mathematics. So virtually I can say only 2 number of questions were asked from the electromagnetic field theory. No question from antenna, no question from transmission line, no question from electromagnetic wave propagation. Probably it has been ridiculous. From the computer organization, again and again they had been keep talking about the new syllabus, but no question from the computer organization. Similarly, no question from the circular waveguide. In the same sequence, from the engineering mathematics, 10 number of questions are being experienced, and similarly in general aptitude in standard, 5 questions had the weightage of 1 mark and the 5 questions had the weightage of 2 marks. Yes sir, I am your live class student and EMFT में कुछ अच्छा नहीं आया sir. Yes. Ajay, we can't do anything for that. Anyways, let me do one thing. Let me straight away hop into the few number of questions which we had consolidated for you guys. पेन ड्राइव में डाल दिया ना अपन ने इसको? जी सर। रीड कैसे नहीं कर रहा? पेन ड्राइव लगा ही नहीं है पेन ड्राइव।
नहीं सर, एसडी कार्ड का आपके नाम का फोल्डर है।
जस्ट अ मिनट। एसडी कार्ड? ओके।
सर गेटीसी।
Okay. So let me take few number of questions, and probably I would be covering few number of questions from the mathematics, few number of questions from the control, few number from analog, and few number from EMFT. So total 4 number of different subjects we are going to deal, and once we are done with that, the next session is going to get handover to probably aptitude, and few number of questions will be taken by Das sir and subsequently Renu sir. So this has been the first question in your board. This has been the first question in your board. May I know what had been the best most answer for this given question? This question had been framed based on the concept of Routh-Hurwitz. It had 2 marks and the type of question was MCQ. May I know what had been the best most answer? What you guys had got this answer? So what was your answer? What was your answer? I would like to have the input from each one of you. What was your answer? The problem states, consider an even polynomial. Obviously all of the even terms are being present over this polynomial. Is given by p of s is equals to of s to the power of 4 plus of 5s square plus of 4 plus k, where k is an unknown real parameter. The complete range of k for which p of s has all its roots on imaginary axis is been. Anyways, how we could have solved this problem? Either you can use the concept of Routh-Hurwitz table, or I would say you need not to go even in that Routh-Hurwitz table business at all. Just focus over a simplest form of the calculation. As it had been an even polynomial, what we could have done, I could have taken s square is equals to of x. So this biquadratic polynomial must have been converted into the quadratic equation. So once the x square is being fed as s, the complete equation becomes p of x is equals to of x to the power of 2 plus of 5 of x plus of 4 plus of k. And in this problem they had been talking about the roots, so obviously we are going to find the root of this quadratic equation. So with the help of Sridharacharya rule, we are going to get the 2 roots. It's been x1 and similarly it's been x2. x2. And how it's been defined? It's been defined as a minus of b, that has been minus of 5, plus minus of b square. What had been b square? B square is going to be 5 square, that had been 25, b square, minus of 4 times of AC. A has been 1 and C has been 4 plus K, and now the 4 is going to get multiplied, so here it becomes minus of 16 and here it becomes minus of 4K, and towards denominator side it is going to be 2 times of A, and that had been to itself. Once we get the value of x1 and x2, for getting the value of S1, S12, S13, S14, what we had to do? We had to take the square root. So what we can do? Easily we can find the 4 different roots that had been S1, S2, S3 and S4 by taking the square root. Once we'll be taking the square root, plus minus sign is going to come. You can say it's S1, S2, and similarly plus minus x2. And in this problem it had been clearly said that the required root has to be pure imaginary in nature. What does that mean of it? That means the x1 and x2 has to be pure negative real quantity. If the x1 and x2 is been pure negative real quantity, by default it is going to generate the pure complex number. So the outcome which we are going to get out of it now, we had to ensure, my dear friend, this complete number has to be negative. This complete number has to be negative as well as real. For keeping this complete number as real, there should not be any negative business within the square root. That means the 25 must be greater than the value of 16 minus of 4K. Agreed what I am saying? Yes, so I can say 25 must be greater than the value of 16 minus of 4K. 16, or I can say 16 plus of 4K. Yeah. So 25 getting subtracted with the 16, that becomes 9. I can say the K has to be lesser than 9 divided by of 4. Even we can take the equals to sign as well. Yes, if you'll see the option A, B, C, D, only option C has that range towards the higher side. So obviously option C must have been the best most answer. Anyways, if you'll be talking about its left hand side, yes, we can discuss about that also. My dear friend, I had made sure that the square root had been dealing with a positive number, but this number should not go beyond plus 5. If it happens, what would happen? If this value goes beyond 5, what would happen? Minus 5 plus of maybe plus 6. In that case, minus 5 plus of 6 would become plus of 1, and once you will take its square root, it is not going to be a pure imaginary in number. So this has been the highest range of the K, and now we will be talking about the lowest range of the K. And there we had to ensure this value 25 minus of 60, this one, 25 minus of 16 minus of 4K has to be lesser than the value of what? See here, square root. Within square root, we don't want this value to be exceeding as 5. So definitely square root should be lesser than 25. And once you'll solve this value now, see what had been happening over here. You can see here very well. 25 minus of 16. How much it had been? 9. It's been 9. Yes, 9 is going to get subtracted with 25. How much it has been? 16. So minus 4K has to be lesser than what? 16. And once the minus sign has been shifted towards right hand side, here also a mistake major of the people do. When the minus sign has been multiplied both other side, the sign gets flipped. So here I can say the 4K has to be greater than the value of minus 16, or K has to be greater than minus 4. So virtually speaking, I don't want to create any of the negative sign inside, and at the same time this square root business should not go beyond plus of 5. From there we have got the lower as well as the upper range, and yes, the least range has been minus of 4, and similarly the upper range is been 9 by 4. So as far as this problem is being concerned, the C has been the best most answer. I would like to have the input from each one of you. How many of us had got this answer? How many? Yeah. In the same sequence, I think it's been the right time focusing over the next question as well. So here comes the next question. This question is being based on the concept of analog to digital DAC ADC, which we had seen as a part of digital. But yes, this has been a problem of analog as well, because we had been dealing with the ideal operational amplifier, and here the R2 2R ladder is being intacted to this operational amplifier. May I know what would be the best most answer? So here comes the next question. So I would like to have the input from each one of you, the student who had attempted this problem. May I know how much answer you have got it? So here we had the 2R, 2R, R, 2R, R, 2R, R, 2R, 2R, 3R, and here we had the ideal operational amplifier, which had the source voltages as plus 15, minus 15, and here V out is being intacted. Consider the circuit shown with an ideal operational amplifier. The output voltage V0 in volt rounded up to 2 decimal places is being. So may I know what would be the best most answer for this given question? So the student who had seen this kind of problem must have smashed this problem within a fraction amount of time. See, this has been a standard R2 2R DAC or standard R2 2R ladder circuit. See what had been happening. You just see how many times this 1.6 volt had been jumped, reaching to this point. See, this has been the first jump, this has been the first jump, this has been the second jump, this has been the third jump, and this has been the fourth jump. So the impact of 1.6, which had been reaching to this node, had been taken 4 steps. So virtually speaking, the effect of 1.6, which is going to come across this node, is simply gonna be 1.6 divided by 2 to the power of number of steps which had been taken. So here it had been 2 to the power of 4 only. If you want, I can use the Thevenin theorem to explain the thing into the much larger or much deeper way, but I think this is not the right time to discuss in that detail, because you guys want actually exact answer. Yes. Similarly, if we'll talk about this has been 0, so even if you'll transfer, still the impact of this ground is going to be 0 volt only. I had been using superposition. Similarly, if you'll be focusing over this 1.6, the number of steps the 1.6 has been taken to reach till this node is been 2. So obviously, once we'll be taking the superposition theorem, what had been happening, now this 1.6 had been taken the 2 number of steps. So it is going to be 2 to the power of number of steps. We had to add them this value, and the values are being chosen in such a simplest form that you don't have to bring even the calculator into the picture. What happens? 1.6 divided by 2 to the power of 4, that becomes 2 into 2, that's been 4 into 8, then 2, it becomes 16. 1.6 divided by 16 will make it 0.1. 0.1. Agreed? Similarly, 1.6 divided by 4. 1.6 divided by 4 will make it 0.4. 0.4. So if we'll be applying the superposition, the effect of this 2 voltages which had been experienced at this node has been 0.1 plus of 0.4, and that had been 0.5. And now you can take the Thevenin equivalent of all of R to 2R circuit, and its Thevenin equivalent is simply gonna be the effective voltage which we had been experienced is simply gonna be 5 volt. Here the Thevenin resistance is supposed to come, and here the feedback resistance is supposed to come. Here it becomes 3R. Here it had been grounded, and even the supply voltages are also been clearly given in this problem. Yeah, this has been the complete case. Yes, sir. My dear friend, you could have seen, once you'll see 2R in parallel with 2R is been R, R in series with R is been 2R, 2R in parallel with 2R is been R, R in series with R it's been 2R, 2R in parallel with 2R is been R, R plus R it's been 2R, 2R in parallel with 2R it's been R. Yes, so one thing has been quite sure, the effective RTH which we will be seeing from this side, RTH is simply gonna be R, and VTH which we had calculated already, it's been 0.5 volt. Yeah, that is for sure. Yes, and resistance has been R, that would come in series with the 2R, so effectively the resistance which we had been experienced over here, it's been 3R. Agreed, no? Now easily we can get the output voltage which had been the requirement of this problem is been V0 is equals to, it's been the standard inverting amplifier, the amount of gain which we are going to experience is simply gonna be minus of RF divided by of R1 getting multiplied with 0.5 volt. And yes, the answer which we are supposed to get, it's been minus of 0.5. So whoever have got the answer as a minus 0.5, that had been the perfect most answer. That had been the perfect most answer. I would like to ask from each one of you, this complete figure has been clearly visible to all of us, na? Otherwise I will be using the image. Yes? This has been the second question. Second question. In the same sequence, I think it's been the right time focusing over the next question as well. So here comes the next question. This problem was a problem from mathematics side. Focus over this problem. Read the problem carefully and tell me what could be the bestmost answer for this given question. So problem states, the value of the integral double integration d 3x square plus of y square dx dy, where d is the shaded triangular region shown in the diagram, is rounded up to the nearest integer. That means if you will be getting the decimal number, then also you have to round up to its nearest decimal number, or sorry, integer number. And this has been the hedged region. This has been the hedged region, this one. Yes. So let me focus over the mathematical expression through which we are going to analyze the complete problem. So here comes the mathematical expression. May I know this mathematical expression talks about? It talks about the volume calculation. This has been the function of x and y, and this has been the differential area. So obviously we had been calculating the volume which had been occupied by a plane 3x square plus of y square surface, and this has been the projection of a triangle. Anyways, this has not been the right time to discuss more about it. Let me straight away jump into the calculation as well. Yeah, see what had been happening. 3 has been a constant value, has been brought it out. X square plus of y square dx dy. Once you'll see this problem, you'll get to know in first quadrant and fourth quadrant the same amount of area is being enclosed. Not only that, even the function is being x square plus of y square. Towards the upper side, towards the lower side, the value of x remains positive. I do not have any problem. But towards the upper side, the y remains positive. Towards the negative side, lower side, the y remains negative. So one thought do come into the picture. Should I be doing the integration of area first half and second half separately, or we can do once through? We can do once through because the function has been chosen in such that the worth of x square plus of y square in this complete region, upper region and lower region, would remain same. I would like to ask from each one of you, if the problem must have been y to the power of 3, could have done this calculation, I could have done in once through? No sir, I can't do in that case in once through. So what had been my next experience? I would just be taking the area under the upper curve or lower curve, and I would be just multiplying with 2, and in that case what happens, the 6 has been as it is. Here comes x square, here comes y square, here comes dx, and then comes dy, and then come di. Yes, na? See what we had been doing over here, as I had been talking about, we had been taking a smallest differential area y dx. So obviously it had been a vertical strip through which I would try to cover the almost all area. So area under the curve formula we had been using over here. So here it becomes so what we can do over here, see 6, at very beginning the integration is going to be y dx, what I am saying, y dx. So here it becomes dy. May I know what's going to be the lower limit? The lower limit is being kept over the x-axis. At x-axis the value of y used to be 0, and towards the upper side you must have seen it had been a straight line which has been crossing through 0, 0, 4, 4. Definitely this straight line is been y is equals to of x. That is why everywhere it had been matching its ordinate and abscissa. Yeah, so here it becomes y is equals to 0 and goes till y is equals to of x. Agreed? And then we would be taking the limit as well. May I know the limit of x would be? The limit of x is going to be from x is equals to 0 to 4. So x is going to be from 0 to 4. 0 to 4. Yeah. And here it becomes dx. Anyways, what we are going to do over here? So the complete fundamental of x square plus of y square dx dy is supposed to come over here. And now at very beginning we had to do the integration with respect to the y. So it becomes x square into y plus of y to the power of 3. End of the day, the calculation is already been brought in front of us. So I would just be using those calculation because I don't want to waste you guys time. So the calculation is already been done where it had been. Just a minute. So yeah. So the calculation is already been done. This had been somewhere 3 had been outside, and then we had 2 y cube, and this value has been ranging from 0 to 0.5 plus 2 x cube. It had been ranging from 0 to 0.5. Why I have done it so? My dear friend, the x square and y square has been an even function. 2 could have been brought it out, and rather taking the integration from minus 0.5 to plus 0.5, I could have done the value in this way, and towards denominator side it must have been 3. It must have been 3. So what had been happening? 3 and 3 is going to go out. Next, y to the power of 3, the 0.5 is being raised to the power of 2. 0.5 into 0.5 is going to be 0.25. 0.25 into 0.5 is going to be 0.125. 0.125 is going to get multiplied with 2. That becomes 0.25. 0.25 plus of 0.25 is simply going to be 0.5. So whoever have got the answer as a 0.5, that had been the bestmost answer. May I know whether we have got it the same answer or what? I would request to each one of you have two-way communication. If you have got something else, you could have put it over the live chat as well. Is that part clear? So this has been the third question. Probably the first question was based on the concept of control. Second question was based on the concept of analog. Third question has been based on the concept of mathematics. Now I think it's been the right time focusing over the next question as well. This has been a problem from analog, and I can understand many of the students could have left this problem because this has not been that straight problem, or the way we used to deal with the diode. No, generally clipper, clamper, DC analysis of the diode, but mostly we do not do the study of the diode in a small signal analysis. That is why many of the students must have got the wrong answer over here. Anyways, let me go back, and this has been the remaining portion of this circuit. So this has been the complete question. Focus over this problem and tell me what could be the bestmost answer over here. Problem states a circuit and the characteristic of the diode D in it are shown. The ratio of minimum to maximum small voltage gain V out versus V in, or the dou V out versus dou V in, is rounded up to the 2 decimal place. So see what had been happening. Once you'll focus over this problem, no, basically the input is being applied towards this side, and the input must have the two part. The first part must have been the biasing part, which will be biasing the given diode. Maybe in this working region, or maybe in this working region. This has been the working region where the diode is been off, and this has been the working region where the diode is been on. Yeah. And at the same time, as we had been doing the analysis with the gain and all, obviously the input should also be a small signal, time varying signal. So what I'm saying, virtually speaking, this problem must have been this sort of feature. The polarity of the voltage may change, the value of voltage may change. Yes, and here we had a sinusoidal signal. Take, and this has been the VI characteristic of the given diode. As you can see very well, this has been almost ideal diode, provided the value of V cut in has not been 0 in this problem. The value of V cut in has been 0.5. Just try to understand in this way. If the diode is been on, definitely the voltage drop across the diode is gonna be 0.5 volt in DC environment. And in that case, you must have seen the voltage and current had been independent to each other. And if we'll be talking about the slope of this graph, may I know how the slope is being defined? The slope is been nothing but the rate of change in y over the x, and the y-axis is being dedicated towards the current ID, and the x-axis is being dedicated towards the voltage VD. So the slope is simply gonna be the inverse of dynamic resistance, which had been forecasted over the diode in AC environment. So may I know what would be the dynamic resistance at this operating condition? 1 upon R dynamic is being very same as the slope offered by this graph that had been infinity. So the value of R dynamic which we had been experienced at this working condition is being simply 0 ohms. 0 ohms. Yes. And similarly, if we'll be talking about slope over here, that had been 1 divided by of R dynamic. 1 divided by of R dynamic, and the slope is being 0 over here. So the value of R dynamic which we experience over here, it's been infinity. So virtually speaking, we would be taking the two different conditions when we'll be doing the AC analysis of this circuit. Once we'll be keeping diode off, and once we'll be keeping diode on, or once we'll be keeping diode as R dynamic 0, and once we'll be keeping a diode as a R dynamic infinity, and through that particular new circuit we are going to get the gain. Now, could you really understood what had been the basic understanding behind this problem? This has been a small signal analysis of the diode. So diode has to be replaced with its dynamic resistance when we will be doing its AC analysis. During AC analysis, the diode has to be replaced with its dynamic resistance, and at the same time all of the DC sources must have been killed. So yes, we will be killing this DC sources, and this diode would be replaced with R dynamic. Now we had taken the two different scenarios. Let me take the first scenario where the value of R dynamic is being taken as 0, the second scenario where the value of R dynamic is being taken as infinity. And yes, as we had been doing the AC analysis, the DC part is going to be smashed out. So first we are going to take R dynamic as 0. This has been the working condition of the diode, and then we had been taking R dynamic is equals to infinity. Let me redraw this circuit once again. So this circuit becomes 2 ohm, 2 kilos actually it has been. Then here comes 2 kilo, all the way this diode offers the dynamic resistance that had been 0, and here comes 2 kilo. Here comes 2 kilo. Yes. And this has been V in plus minus, and here we had been taking V out. So easily we can apply the voltage divisor rule, and this resistance has been clearly bypassed through this conducting path. So obviously parallel combination of 2 kilo versus 0 ohms is being 0. So here it had been simply equals to what? This has been V out versus of V in, or I can say rate of change in output versus rate of change in input is been simply equals to of how much? 2 kilo divided by 2 kilo, and that had been 1 by 2, and that had been 1 by 2. Agreed now? Yes sir. Now in the same sequence, what we can do over here, now we will be keeping this as an open circuit, and you yourself would be able to understand, my dear friends, what would be the output voltage. So the output voltage is going to be, it's been open circuited, 2 kilo had come in series, so here it becomes 4 kilo. Across 4 kilo we had been taking the output voltage, and in series we had the 2 kilo as well. So I can say this has been dou V naught versus of dou V in. From the voltage divisor rule, the 2 kilo and 2 kilo is going to come in series. It's been 4 kilo divided by a 4 kilo plus of 2 kilo, that had been 6 kilo. So the worth which we had been getting over here, it's been 2 divided by of 3, the kilo and kilo is going to smashed out. And in this problem, you can see the rate of change in voltage versus input is been half, and here it had been 2 by 3. And in this problem they had been asking about the ratio at which the output versus input is been measured in case of minimum and maximum. Where it had been minimum, obviously the 1 by 2 has been a minimum value and 2 by 3 has been a maximum value. So what we are going to do, end of the day, the ratio has to be assessed over here. 3 is been flipped upside, it remained 3, and 2 into 2 is been 4. 3 divided by 4 is being 0.75. So as far as the ratio of the minimum to the maximum, a small signal voltage gain, dou V out versus of dou V in is being concerned, the answer must have been 0.75. Yes. So may I know how many of us have got this answer as 0.75? I can see approximately 26-25 number of students are being concurrently live. At least I would like to have at least one input, so I would be able to understand how far you could manage today's electronics paper. Tell me. Then we would be moving forward, taking the next question as well. ऐश्वर्या मैम को बोल देंगे ना कि आप तैयार रहेंगे करके, मैं बुलाऊंगा आपको करके. So here comes the next question based on the concept of Cauchy's integration within the concept of complex variable. Read the problem carefully and may I know the student who had smashed this problem, what had been their answer? The problem states the simple closed path C in the complex plane is being shown in figure. Figure is not been properly visible. Anyways, I have got this figure, so I am just writing it out over here. So here we had closed contour integration of 2 to the power of z divided by of z square minus of 1 d of z is equals to of minus I pi a, where the iota is being root over of minus 1, then the value of a is being rounded off to 2 decimal place, and this has been a closed contour, and yes, the direction is being anti-clockwise in nature. So a student who had cracked this problem, probably they must have got the value of the a as well. I would like to have the input from all of those students. May I know what was the best most answer? So here what we had been doing over, we are going to use the Cauchy's integration, and as far as Cauchy's integration, just a minute, as far as singular points are being concerned, no, all of the poles used to be the singular points. Z square minus of 1 is being compared with the 0, and we have detected the 2 poles, and they had been at plus 1 and minus 1. But among plus 1 and minus 1, only minus 1 is going to get encircled. That means within this complete closed contour, only and only one non-analytic or singular point we had. If we did not have any of the singular point, the value must have been 0, and in that case the value of a should also have the value as 0. But here one singular point is being encircled, so we had to take care about it. So what we can do over here, we can use, or we can take the reference of residue theorem as well. So here we could have taken 2 to the power of z divided by of z plus 1, z minus 1, we had factorized its denominator, dz is equals to of 2 pi I residue of the each and individual poles which are being encircled, or residue at each and individual poles which had been encircled. So only and only it had been encircled at minus 1, 0. So I can say I would be calculating a residue at z is equals to of minus 1. Z is equals to of minus 1. Agreed, no? So this has been 2 pi a. Residue at z is equals to of minus 1. How we will be calculating that? 2 to the power of z divided by of z square minus of 1 has been factorized. So obviously the factor which we had been getting over here has been z plus 1, z minus 1. And then we are going to multiply it with the z plus 1. And here the limit would be fed. Limit would be fed as z tends to minus 1. Anyways, this part you must have seen in case of Cauchy's integral. So just only one step has to be further followed, and we'll be getting the answer from here. 2 pi I remains as it is. Yes, sir. Remains as it is. Now z has been placed as minus 1, so 2 has been raised to the power of minus 1, and towards the denominator side what had been happening, z plus 1 is already been smashed out. Now the z is being placed as a minus 1 becomes minus 2. Yes, so end of the day the result which we are supposed to get over here, it's been see, 2 and 2 is being smashed out. 2 to the power of minus 1 could have been written as 1 upon 2, so the factor which had been received is been pi I divided by of 2. Once we'll be comparing these two factors, no, minus I pi A, we will be getting the value of A as well, and that had been 1 upon 2, and that had been 1 upon 2. So whoever have got the answer is 1 upon 2, that had been the best most answer. That had been the best most answer. Agreed, no? In the same sequence, I think it's been the right time focusing over the next question as well. Let me focus over the next question. Yeah. So here comes the question number 10, and this problem had been picked up from the concept of operational amplifier, and probably they had been talking about the frequency responses. So here comes your complete question. Read the problem carefully and tell me what was your best most answer. The problem states an ideal operational amplifier with a sinusoidal input is shown in figure. The 3 dB frequency is the frequency at which the magnitude of the voltage gain decreased by 3 dB for maximum value. Which one of the options is R correct? Keep in mind this has been a problem of MSQ and probably it carries 1 mark. This has been the standard circuit. First we had to figure it out which kind of filter it had been. My dear friend, I think if you are not well aware with the functioning of active filter, then also you would be able to crack this problem easily. The reactance offered by the capacitance, how it's been defined as a 1 divided by f2. Anyways, we also know the reactance which had been offered by the capacitance is being inversely proportional to the f. And if the input which has been supplied to the complete circuit is been operating at DC side at very lower frequency, what would happen? In case of frequency, f is equals to 0. F is equals to 0. The reactance offered by capacitance is being infinity because the f becomes 0, xc becomes infinity. That means this complete input is being completely isolated. No input is being injected to the complete circuit. The V out is being completely 0. V out is being 0. V out is being 0. Agreed? In the same sequence, if we'll be moving forward, and if we take a very high operating frequency, let's take, theoretically speaking, f tends to infinity. Reactance offered by this capacitance becomes 0, and in that case, obviously, the gain would be offered by the system, and that would be minus of Rf by R1. And V naught is equals to of minus Rf by R1, and if you'll be talking about its magnitude, it's been simply 2. It's been simply 2. So one thing has been quite sure, towards a lower operating frequency, high attenuation is being offered by this filter. So I can say the type of filter it had been a high pass filter. So the option D probably must not be visible to all of us, but the D has been the perfect most answer. D has been the perfect most answer. Now, the student who had a little bit idea about the high pass filter, may I know the 3 dB cutoff frequency, what used to be the worth of it? A small derivation part is being involved. The operating frequency at which the gain offered by the system reaches to the 1 upon root 2 times of its maximum value. And that 3 dB frequency is just been decided by this limb. So I can say the 3 dB frequency in radian per second, omega 3 dB is equals to of 1 divided by R, that had been 1 kilo, into C, and that had been 1 micro. 1 kilo into 1 micro becomes 10 to the power of minus 3. 10 to the power of minus 3 has been shifted towards upside, and this has been 10 to the power of 3 radian per second. Yes. So whoever have marked the option C and option D has been the correct answer, that they are going to get the complete answer. Yes. So in the same sequence, I think it's been the right time focusing over the next question as well. This has been a problem from EMFT. Let me focus over this problem based on the concept of Coulomb's law. which is also called as a Gauss law. Probably many of the student thinks the Gauss law and the Coulomb's law are been completely independent. No, they had got the bridge. So I can say the Gauss law for the time being. What the problem states, in a electrostatic field, the dielectric displacement density D vector is being given as x cube ax cap plus of y cube ay cap plus of xy square az cap coulomb per meter square, where I, j, k are being unit vector along x, y and z axis respectively. Consider a circular region R centered at origin with each side of length 1 meter, vertices plus minus of 0.5 meter, plus minus of 0.5 meter, plus minus of 0.5 meter. The electric charge enclosed with R is being. So probably you must be knowing the theory. The net electric flux coming out from any of the closed surfaces is very same as the net amount of electric charge which has been enclosed by the given closed surface. Mathematically speaking, this could have been written as net electric flux coming out. Mathematically it could have been written as closed surface integration of d dot ds is equals to of q enclosed, is equals to of q enclosed, q enclosed. Electric flux density vector d vector is being clearly supplied over this problem. So we could have taken its volume surface integration with this given sides. The sides are being kept at x is equals to plus 5, x is equals to minus 5, y is equals to plus 5, y is equals to minus 5 and z is equals to plus minus 5. Actually, it had been encapsulated from all of the sides. It's been a type of cube. So yes, we could have taken the 6 different segments. We could have calculated how much amount of flux is being lived out, and according to that we could have calculated the value of Q enclosed. But we could have used the concept of divergence theorem as well, which will simplify the complete calculation. What we could have done over here, this could have also written as volume integration of del dot D, and the region at which the volume integration is to be performed is been the region which has been enclosed by this surface. Yes, so obviously all the way the x has been moving from minus 0.5 to plus 0.5. Same goes with y and same goes with the z as well. Same goes with the z as well. Yeah, so let me start taking the divergence of the each and individual factor. The ax cap is being multiplied with the x cube, the differentiation with respect to the x partially. So the factor which we are supposed to get, it's been simply of 3x square, and then here it becomes 3y square, and no z component is being involved with a z cap, so definitely this factor is simply going to be 0, and here we get dx, dy and dz. And the variations in the x, y and z are being clearly known to me. The x is being moving from minus 0.5 goes till plus 0.5, and same goes with the y and same goes with the z as well. At very beginning, let me start doing the integration with dz. You can see very well the function is being independent from the z. So once you integrate with respect to the dz, the integration of the dz is simply going to be z. Upper limit is going to be 0.5 and lower limit is going to be minus 0.5. 0.5 minus of 0.5, that becomes 1. So simply speaking, I could have done one thing. I could have smashed this integration. I could have smashed this dz. I could have smashed this dz. Agreed now? And yes, here the value of y had been moving from minus of 0.5 to 0.5. In next step, what we can do, the 3 has been a common factor. Obviously, sir, we had brought this out. We had brought it out, and now we had been taking the integration, and the integration of x square. May I know what would be the integration of x square? The integration of the x square is going to be x to the power of 3 divided by 3. Agreed, sir? And this 3 and 3 is going to get smashed out, and as the 3 and 3 is going to get smashed out, the factor which had been left out is been simply x square and y square. So virtually speaking, I can simply say, see, 2 had been come out, so the factor is simply going to be 2, and within the bracket the factor which has been left out is being 0.5, which has been raised to the power of 3. Yes, and 3 had been towards denominator side. So already the calculation is being made from my side. Let me check it out, how much answer we have got it for it. So may I know how much answer you guys have got it? So the answer is supposed to come as 0.5 coulomb. Whoever got the answer as 0.5 coulomb, that had been the perfect most answer. In the same sequence, I think it's been the right time focusing over the next question as well. So here comes your next question. So this problem is being based on the concept of line integration, vector line integration. Let me bring this problem towards working board and we will try to smash this problem out. So here comes the part of the question and the second part of the question comes over here. So yeah, again it is not been completely visible. Read the problem carefully and tell me what was your answer. The problem states, consider the two-dimensional vector field f vector which has been a function of x and y, and that had been written as, just a minute, this has not been properly visible, x ax cap plus of y ay cap. Yeah, this has been x ax cap y ay cap x comma of y, x comma of y, and this has been f vector. This has been the f vector. Yes, and they had been looking for closed line integration. This part is not been here, it's been absent. Closed line integration of f vector, which is the function of x and y only, dx I cap plus of dy j cap, dy j cap. One thing has been quite sure, if you start from any of the point, all the way you had been coming back to the same point if you follow the complete path. Yes, all the way you had been coming through the same point. So you can use the concept of Stokes theorem, either you can use the concept of Green's theorem. It's been your choice. But I would suggest to each one of you, if you could have used the concept of Stokes theorem, easily you could have figured out the answer. See what the problem states. We had been looking for the closed line integration of this given vector function. And as far as this vector function is being concerned now, this vector function is being path independent, curl free, irrotational. What does that mean of it? That indicates if you start from the first point and all the way, if you come back to the same point, its closed line integration would be 0. Is going to be 0. Is that part clear? So irrespective of the structure which we had made, whether it had been made towards left hand side, right hand side, whether it had been flipped towards the fourth quadrant, or either it had been flipped towards the maybe second quadrant, in all of the sequences, if you start from the one point and all the way, if you come back to the same point, you can use the Stokes theorem, and as the curl is being 0, the f vector is being path independent, and as the f vector is being path independent, its closed line integration is being simply 0. Yes. Anurag, do you have any doubt? Amplitude में 360 guard मिला था. I'm not able to understand. Anyways, if you had any sort of query, you can put it over the live chat. We can have the discussion over those questions as well. If those questions belongs from this 4 number of subjects. I had been dealing mathematics. I had been dealing control. Then if the problem falls from analog or from EMFT. Anyways, I would be dealing with the devices as well, but probably Das sir is going to take the remaining question from the devices. So if you have any sort of doubt, now you can ask. I am having all sort of questions. So whoever have got the answer as 0, that had been the perfect most answer. In the same sequence, I think it's been the right time focusing over the next question as well. So here comes the next question, a simplest form of the problem. The student who had a little bit idea about the root locus could have easily smashed this problem out. May I know what had been the best most answer? So here comes the question number 14. Here comes the question number 14. Option D is not been visible, and probably option D is only the answer. Sir, solution of Nyquist plot. I had not seen that problem. Let me see that. Then only I would be able to comment anything. Sir, I have used the Green's theorem and I have got the answer as 0. That's been perfect. That's been perfect. One thing has been quite sure. Once you'll be talking about the real axis existence of the root locus, no, you could have figured it out. The part of the real axis existence do takes place towards the left hand side of S is equals to of -1. What does that mean of it? That means from here onwards, if you'll be counting the number of poles and zeros towards right hand side, they has to be odd in nature. Yeah, they has to be odd in nature. So once you'll check option A, B, C and D, the D is going to be the bestmost answer. That's been the first way. That's been the first way. And even I can understand many of these students must have trapped over this point as well. If I'll say s to the power of 5 plus of 1 is equals to 0, you had to find the roots of this. I know many of these students are going to get stuck at this point. This problem can be easily solved with the help of complex variable. Plus 1 had got towards right hand side, that becomes minus of 1. Minus of 1 could have been written as e to the power of minus iota pi by 2. 5 could have been again brought towards the right hand side, could have been 10, and we could have expanded it. Keep in mind, obviously we can see very well all of the roots are being placed at real axis only, and only one answer had come in our hand, and that had been D. Anyways, a lot of concepts are being involved with this problem, but probably this has not been the right time to discuss about the detailed study. Agreed? So I think it's been the right time taking the next question as well. So here comes the next question. No, this has not been my area of concern. This problem is already been taken at very beginning. Nah? Yeah, this has been the next problem from the mathematics. Focus over this problem and tell me what could be the bestmost answer over this problem. They had been talking about the nature of solution this problem would carry. Here comes the question. Here comes the question. Problem states, consider a system of a linear equation Ax is equals to B, where A is being a 2 cross 3 matrix and B is being a column matrix. The system equation admits a unique solution for X, no solution for X, exactly 2 solutions for the X, infinitely many solutions for the X. No solution, yes. Whoever have got the answer as A, that had been, no, not unique solution, no solution. Why it had been happening so? So the number of variables which are being attached along with this problem is been clearly known. It had been 3. So it had been 1 minus of root 2, and here it had been 3 minus 1 root 2 minus of 3. And let me multiply with x1, x2, or even I can write x, y and z. X, y and z. And had been compared with, so it had been.
Sir, वो आपके के क्वेश्चंस टाइप होने के गए थे ना, तो क्वेश्चन में शीतल भैया का नाम लिया, शीतल भैया आपसे बात करने को बोल रहे हैं, तो वो दोनों एक बार जो टाइप डेमो भिजवा दें.
Yes. Let me start multiplying them. So this becomes x1, this becomes minus of root 2 times of x2. This becomes 3 times of x3, and this has been 1. Minus of x1 plus of root 2 times of x2, and here it goes minus 3 times of x3. And if you'll be comparing with the right hand side, this has to be 3. This has to be 3. And one of the amusing thing regarding this problem is being, once you'll be multiplying the minus sign in first equation now, the left hand side becomes minus x1, right, minus becomes plus root 2 of x2, and plus becomes minus 3 times of x3. But this 1 is not becoming minus 1. That means together this equation cannot be correct. मैं ये बोल सकता हूँ कि झूठ बोल रहा है. Yes. तो मैं बोल रहा हूँ at one shot either this equation can be true, either this equation can be true, because the left hand side is being multiplied with the minus sign. So virtually speaking, right should also get multiplied with the minus sign, but that has not been the case. And that happens when we had got the two different planes. My dear friends, this has not been the problem of a straight line, this has been the problem of plane, if two planes are not been meeting at any point. Yes, with the help of rank also you could have smashed this problem. So the student who have got the answer as no solution, that had been the best solution. In the same sequence, I think it's been the right time focusing over the next question as well. I exactly do not know how many questions are being there from our side, which I would be dealing. Yes, we can take this question as well. So here goes the next question. The problem had been picked up from the analog circuit frequency response analysis. Read the problem carefully and tell me what had been your response in gate examination. क्या हो गया इसको, ये focus on this problem. The problem states a circuit with an ideal operational amplifier shown. The Bode plot for the magnitude in dBs of gain transfer function A over j omega is equals to of V naught j omega V in j omega of the circuit is also provided. Here omega is being angular frequency in radian per second. The value of R and C are being. This has been your standard circuit and this has been your frequency response curve. My dear friend, once you'll see this problem, few of the important outcome we can extract. From 12 dB to 9 dB, the reduction in 3 dB had been taken place. So I can say that this 3 had been your minus 3 dB operating frequency. But the data had been given in log. That means log base 10 had been 3. Once you'll be taking its anti-log, and anti-log is nothing but the exponent. Yes. And the exponent is being raised by its base. So the value of omega is being, exponent is being raised to its base 10 to the power of 3. That means I can say the 10 to the power of 3 that had been 1000 is being the cutoff frequency or the 3 dB frequency. 3 dB frequency. Yes. And this 3 dB frequency would be equals to 1 upon tau. And how the tau would be defined? The tau is going to be the multiplication of this resistance and this capacitance. So this has been 1 divided by the worth of the resistance is been 10 to the power of 3. And similarly, the value of C is to be calculated. C is to be calculated. How it's possible? The value of C has to be 10 to the power of minus 6 such that 10 to the power of 3 into 10 to the power of minus 6 would become 10 to the power of minus 3, and 10 to the power of minus 3 would get shifted towards the upside, and from there I would be getting the value of C. So the value of C which we are being needed is being 1 microfarad. Yes. As far as this problem is being concerned, in out of 4 number of options, 1 micro is being placed only in option A and option D. Option A and option D. Yes, yes sir. Now they had been talking about the value of this resistance as well, the feedback resistance probably. You can see very well at lowermost operating frequency, highest gain is being offered by this given system, and at lowermost operating frequency the reactance which would be offered by this capacitance would be simply infinity. That means whatever the voltage is being applied across this terminal, all the way it had been experienced by the non-inverting terminal, and the gain which would be offered by this system is going to be 1 plus RF by R1. I can understand many of the students must have done the mistake at this point. May I know how many of us had done the mistake over this point? I know approximately 30 to 40% student had made a mistake over this point. Yes, 1 plus of RF divided by of R1 getting multiplied with a V in is going to get translated in a form of V naught. So virtually speaking, the highest gain which had been 12, from here easily we will be able to get the answer. So what had been the answer over here? The answer is been A. Okay, so let me see how many questions are being still left out. MOSFET, Das sir is going to take this. Question number 27. Looks a very terrific question, but yes, it's not that difficult. You have to just focus over the basics of this problem. This problem is been based on the concept of astable multivibrator, which you must have seen as a part of analog circuit. What the problem states: for the following circuit with an ideal operational amplifier, actually it has been the difference actually. The word has been the difference between the maximum and minimum voltage across the capacitor VC is been. Now what we had been doing over here, again there has been a mistake. It's been minus of 12 volt. Now let me take this operational amplifier is being saturated towards the positive side. It's been plus 15 volt. In case of plus 15 volt, you can see the direction of flow of current has been in reverse of cathode to anode, in forward of anode to cathode. So this diode is going to be on and this diode is going to be off. So the voltage across the non-inverting terminal is going to be V plus is equals to, this has been on or off, this has been on, so it's simply gonna be R divided by off. All the way, all of the resistances are going to get added, R plus of R plus of R, that had been 3 of R, getting multiplied with the input which has been 15 volt. So the maximum capacitor voltage would be the maximum allowable non-inverting voltage, that had been 5 volt. Agreed? Yes sir. Now in the same sequence, we would be taking the next scenario as well, where the output is being saturated towards the negative side. And if the output is being saturated towards the negative side, it's been minus of 12. And now this is going to get impacted. Now, so may I know what had been the voltage? R and R goes into the series. That becomes 2R. And towards denominator side, we are going to have R. This has been on now. So it had been 3 of R. 3 of R. Getting multiplied with a minus of 12 volt. Minus of 12 volt. So the value which we are supposed to get over here has been RR gone, and here it had been minus of 4 getting multiplied with 2, that becomes minus of 8. And they had been talking about the subtraction. 5 is going to get subtracted with a minus of 8, and yes, the result is been 13. So whoever have got the answer as 13, that had been the precise most answer. So approximately 1 or 2 more questions are being left out from my side, and then we would be moving into the next subject, probably aptitude. So here comes the next question as well. The statement which has been attached along with this problem was too large, but the important data through which we could have solved this problem has been very minimal. Focus over this problem, and we had been focusing over the ratio between the output voltage at terminal A versus terminal B. The ratio of VA and VB has to be calculated. May you know what had been the answer? See, one thing has been quite sure, the data which has been supplied along with this problem states this given MOS is been working into the saturation region. Obviously it had been working as an amplifier, and as it had been working as an amplifier, the drain to source could have been replaced with a dependent source. So what I'm going to do, we are going to take its equivalent circuit, and by taking its equivalent circuit, within a fraction amount of second, we would be able to smash this problem. Even you don't have to lift the pen as well. So what had been happening, here the current which we'll be forcing to flow is being GM into VGS. Here we had 4 kilo. In case of AC analysis, definitely DC is going to get short circuited. And here we would be having 2 kilo. Here we had been getting VA, and here we had been getting VB. Yes, VA and VB. Polarity is going to be plus and minus. So I can say the V would be measured as negative and VB would be measured as positive. So VA, what is going to be VA, VB? VA is simply gonna be minus of 4K into this current, 2K into this current, and end of the day, the result which we are being supposed to get, it's been minus of 2. So whoever have got the answer as minus 2, that had been the perfect most answer. Let me do one thing. Let me go ahead with the aptitude now. Yes, few more questions are being left out, but yes, we would be taking those questions maybe in next upcoming session. Please, ma'am.
Thank you so much, sir. Hello everyone. I hope all of you are doing really well and your paper went really well. So let's start with the very first question. Let's start with the very first question which we have. We do not have typed question. So here I am reading the very first question. Here we have two equations, two inequalities. The first one is 2x minus 1, that is greater than 7, and we have the second inequality as 2x minus 9, that is smaller than 1. Now what we have to do, we have to find out which one of the following expression below satisfy the above two inequalities, and we have options like minus 4 x 4. Option number B is option number C, that the value of x lies between 4 and 5, and option number D is okay. Now if we are solving these inequalities, we can write it as 2x is greater than 8, right, and x is greater than 4. From inequality first, we can write x is greater than 4. That means this option is incorrect, right? But if we solve this also, we will get 2x is less than 10 and x is less than 5. So if we merge both of these, we will get option number C is our answer. If we merge both of these values, then we will get option number C as our answer. This is a very easy question. Okay, now let's move to the next question. Here in the figure, there is a grid formed by a collection of unit squares. All of them are equal and each of the square is of 1 unit. 1 unit, and almost every square is shaded except one. All squares are shaded, right? Similarly like this. Now what we have to calculate, in the figure shows a grid formed by collection of unit squares. The unshaded unit square in the grid represent the whole. This is nothing but this is a whole, right? What is the maximum number of squares with a hole in the interior that can be formed with the 4 cross 4 grid using the unit square? So basically we have to find out the number of squares. And options we have option number A, that is 15, option number B is 26, option number C is 21, and option number D is 20. So if we calculate the number of squares, that means if we talk about 1 cross 1 square, if we will consider 1 cross 1 square, that means we have 15 squares with the shaded part. With the shaded part we have 15 squares. But now if we calculate 4 cross 4 squares, that means 1, 2, 3, 4, 5, right? So with 4 cross 4 we have 5 squares. 9 cross 9 square is not possible, so we eliminate this part and we have to calculate the total number of squares. So total number of squares is nothing but 15 plus 5. That means the correct answer is option number D. The correct answer is option number D. Is it clear? Is it clear? Okay, now let's discuss another question. Here we have 4 points P, Q, R and S. Four points P, Q, R and S. P is with 0, 1. Q is 0, -3. R is with minus 2 minus 1 and S is with 2 comma minus 1. Yes, 2 comma minus 1. What we have to do, we have to calculate, these are the these represent the vertices of equiquadrilateral. What is the area enclosed by the quadrilateral? What we have to do, we have to calculate the area. We have to calculate the area. So how we are going to solve this? First draw the diagram. Here this is 0, this is 1, this is 2, this is 3. This is your x-axis, this is your minus x-axis, this is your minus y-axis, and this is your y-axis, right? This is 1, this is 2, this is minus 1, minus 2, minus 1, minus 2, minus 3, and so on. So the first point is 0 comma 1. 0 comma 1, that means somewhere here. Here we have our point P, 0 comma 1. Now Q is at 0 comma minus 3. 0 comma minus 3. That means somewhere here. This is your Q, 0 comma minus 3. R, that is minus 2 minus 1, minus 2 and minus 1. That means somewhere here. Here we have point number R, minus 2 minus 1. And the last point is 2 minus 1. 2 minus 1, somewhere here. This is your S, 2 minus 1. If we join all these coordinates, and we calculate the distance between P and S, S and Q, Q and R and P, then what we will get? Now let's calculate the distance between P and S. This is nothing but x2 minus x1 whole square plus y2 minus y1 whole square. Okay, this is our formula. So just put the values 2 square plus minus 1 and minus 1, that means minus 2 ka whole square. That means we will get 4 root 8. We will get root 8 as our answer. And if we calculate SQ, QR and RP, these all are also equal to root 8. That means this is nothing but square, but first we have to calculate diagonal as well. So we calculate the distance between P and Q. This is nothing but this is the diagonal. If we calculate this, this will as 0 plus minus 4 whole square. That means this is nothing but equal to minus 4. That is equals to minus 4 ka whole square. That means it is equal to 4. That is equal to 4. So this shape is nothing but it is a square. And if we want to calculate the area of square is nothing but a square. That means root a square. The correct answer is 8. The correct answer is 8. This is a very simple question which we have in our today's examination. Okay, now let's move to the next question, which is from the concept of ratio and proportion. The question is, the sum of money is distributed among P, Q, R and S. Here we have 4 participants, P, Q, R and S. And it is mentioned that the sum of money is divided in the proportion of 5 ratio 2 ratio 5 ratio 2 ratio 4 ratio 3, and it is given that if R gets 1000 rupees more than S, if R gets 1000 rupees more than S, that means the difference is equal to 1, and the value of 1 is nothing but that is equal to 1000 because R is getting 1000 rupees more than S, right? So what we have to calculate, we have to calculate the share of Q. We have to calculate the share of Q, and here we have our options as option A 1000, option B 2000, option C 500, and option number D is 1500. So if the value of 1 is 1000 and Q is getting 2 parts of that, that means we need to multiply it with 1000. So the share of Q is nothing but 2000 rupees. That means option number B is correct. That means option number B is correct. This is a very simple question. Okay, now let's move to the next question. The next question is from your verbal ability. The question is, Mr. X speaks filling the blanks Japanese dash Chinese. Okay, and here we have option A, neither or, it's neither or, either nor, also but, and option D is neither nor. So we know this combination doesn't exist, this combination is also doesn't exist, and here we are not getting any tone to use but and also. So the correct answer is option number D. Mr. X speaks neither Japanese nor Chinese. The correct answer is option number D. That is, Mr. X speaks neither Japanese nor Chinese. Right? This is a very easy question. Okay, now let's move to the next question which we have. Okay, here we have a trapezium has vertices marked as P, Q, R and S. Here we have a trapezium named as P, Q, R, S in the anti-clockwise, sorry. Right? And it is given that the side PQ is parallel to side SQ. This side is parallel. PQ is parallel to SR. And it is given that the PQ is equals to 11 centimeter. The distance between PQ is 11 centimeter. QR is nothing but that is equals to 4 centimeter. RS is 6 centimeter. And SP is nothing but 3 centimeter. Okay, now what we have to calculate? We have to calculate what is the shortest distance between PQ and RS. What we have to do? We have to calculate the shortest distance. Shortest distance between PQ and SR, and here we have some options. Option A, that is 5.76, option number B 1.8, option number C 4.20, and option number D is 2.40. So how we are going to solve this? As you can see, we can draw a parallel line here. Let's suppose we named it as A. So we can say that SP is parallel to RA, right? We can draw a parallel line over here. That is nothing but that is equals to 3 centimeter again. If this is 3 centimeter, then we can say PA is nothing but 6 centimeter because of this distance, right? And the remaining distance, that is AQ, is nothing but 5 centimeter. Right? We can write it as AQ is equals to 5 centimeter. Now here if we can see, here we get a right angle triangle. So how do we calculate the area of right angle triangle? That is it is very simple. That is equals to half into base into height. Right? Let's suppose this is the height. We can name it as B. So we can say like this is equals to half into base, that means 5, half into 5 into height, that is equals to RB, and it should be equal to the S minus A, S minus B and S minus C. Now how do we calculate the value of S? If we have to calculate the value of S is nothing but A plus B plus C by 2. A plus B plus C by 2, that means it is equals to 3 plus 4 plus 5 by 2, 7 plus 5, 12 by 2, that is the value of S is nothing but 6. So we can write it here 6 into 1, 5 minus 6 minus 5, 6 minus 3, 6 minus 4. So here we can write it as, this is square root of 6 into 1 into 3 into 2, that will equal to 6, 36, that is equals to 6. So here we can write it as half into 5 into RB is nothing but that is equals to 5. That means the value of RB is equals to 12 by 5, and if we calculate 12 by 5 we will get our answer as 2.40. That means the correct answer is option number D. That is the correct answer is option number D. Okay, that is equals to option number D. This is a very easy question. Okay, now let's move to the next question. Okay, here we have a question in a class. This is a very easy question based on the simple data. In a class of 5 students, P, Q, R, S and T, P, Q, R, S and T, here we have 5 students. Only student is known to have copied in the exam. Only one student is copied in the examination, and it is given that the disciplinary committee has investigated and situations and recorded the statements from the students as given below. Student P says R has copied in the exam. P says that R is copied, right? Q says R has copied the exam. Q says R is copied in the exam. Next, R says P did not copy in the exam. It says P did not copy in the exam. Next, S is saying only one of us is telling the truth. Only one of us is telling the truth. And the last one is RT is telling R is telling truth. R is telling the truth. Now, what it is asking, the investigating team had authentic information that S never lies. The authentic team says that S never lies. That means this condition is true. That means this condition is true, right? Now, what we have to do, we have to find out based on the information given above, the person who has copied in the examination is, and here we have our option. Option A is R, option B P, option C is Q, and option D is T, right? So if it is clearly mentioned that R is saying truth, that means only one of them is saying truth, right? If only one is saying truth, that means R is telling the truth. This one is lie, right? This one is also lie. This one is also lie, and this one is also lie. If the statement given by R is lie, that is P did not copy in the exam. This is lie, that means P is copied in the exam. P is copied in the exam. That means the correct answer is option number B. This is a very simple question. Here it is clearly mentioned that the only S is saying the truth. That means only one of them is saying the truth. If only one of them is saying the truth, that means this condition is lie, this condition is lie, this condition is lie, and this condition is lie. If this condition is lie, that means P did not copy. That means this is the lie. So the correct answer is P copied in the examination. P copied in the examination. Okay. Now let's move to the next question. Okay. Here we have a question. Consider the following source square with the four corners and the center marked as P, Q, R, S and T respectively. Here we have a square. Right? We have a square like this, and it is mentioned that it is something like this. This is P, Q, R and S. Now what it says that let X, Y and Z represent the following operation. Here we have three operations, X, Y and Z. Here we have three different operations. X says rotation of the square by 180 degree with respect to SQ. With respect to SQ, what we have to do, we have to rotate it by 180. If we perform X operation, that means we will get our square something like this. This is Q, this is S, this is P, this is T and this is R. After the execution of operation X, right? What Y says rotation of the square by 180 degree with respect to PR axis. 180 degree. If we perform Y axis, then we will get our answer, or we will get our square something like this. Here S, Q, R, P and this is T. After the execution of operation Y, and the Z says rotation of the square by 90 degree clockwise. 90 degree clockwise, that means if we perform Z operation, that means we will get our answer or our square like Q, R, S, P. Now it states that consider the following three distinct sequences of operation which are applied in the left to right order. Here we have three operations. First one is X, Y, Z, Z. Option number second operation is X, Y, and the third operation is Z, 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 Z. Right? So what we have to find out, which one of the following statement is correct as per the information provided above. We have to find out which operation is correct, right? So here we have options like the sequence of operation 1, 2 and 3 all are equivalent. Second option is the sequence of operation 2 and 3 are equivalent. So we can also write here we have our options 1, 2, 3 all are equivalent. Option number B. Second and third are equivalent. C is 1 and third are equivalent. Option number D is 1 and 2 are equivalent, right? So if we consider this square and we apply such operations, then we will get, if we rotate the square with this 90 degree clockwise, then we will get the same square again. You can also take it like this is the X, right? This is the first X. Now if we put the second X, the values are like here we get the P, here we had the R, and here we have the S, right? One more Z, that means here this is Q, this is R, this is S and this is P, and the fourth Z. With the fourth Z we will get the same diagram, that is Q, R, S and P, right? Now if we check first condition, so after applying X operation, if we apply the Y operation over here, that means the value of P and R is changed. Here this is R and this is P. So both of these are not equal, that means the combination of second or third is not exist. That means option number B is eliminated, right? The option number B is eliminated and option number A is also eliminated, right? Now let's check after applying Z and Z twice in the same operation, what we will get. If we are applying R, S, P, Q and T, if we are applying Z for the very first time, here we will get our answer as it's S, P, Q, R, and applying Z one more time, what we will get, Q, R, S, P, that is almost equal to this. That means this options do exist. This option is do exist. That means the option number 3 is the correct answer. Option number 3 is the correct answer. Is it clear? Is it clear? Is it clear or not? Please let me know in the comment section. Now let's move to the very last question. Okay, is it clear? Now let's move to the very last question. Here we have a art gallery, something like this. This is the shape of art gallery. Here we have P, here we have R, here we have Q, and here we have S, right? So it is mentioned that the art gallery engages the security guard to ensure that the item displays are protected. The diagram below represents the plane of the gallery where the boundary walls are occupied. The location the security guard posted is identical such that the inner space shaded region of the plane of the gallery is within the line of sight of the security guard. Okay, if the security guard does not move, now the condition is mentioned that the security guard doesn't move and around and the posted location and has 360 view. The guard do not move, but it can move 360 degree along the plane, right? So view which of the following correctly represents the set of all possible location among the locations PQRS where the security guard can be posted to watch over entire inner space of the gallery. And here we have options P and Q, option B Q and S, option C R and S, and option D Q only. Okay, if we posted guard here, then he will get the view of this, but he do not get the view of R because of this shape. That means this P is eliminated and this R is also eliminated, because if we post guard at here, he will get the view of Q and S, but he do not get the view of P. That means the option of R is also eliminated. And if we posted guard either here or here, he will get the view of each and every position. That means the correct answer is option number B. This is all from my side. Now we will discuss some other section. So thank you so much.
Hello everyone. So now I am going to take questions from two subjects, network theory and digital electronics. And according to me, how was the question from network and from digital? So you can say network question was easier to moderate, you can say, and similarly digital question again you can say easy to moderate. So according to me, both the subject, all the question was easier, but for the student definitely I can say from easier to moderate. Okay, and 5 question from network theory and 5 question from digital electronics is asked. Okay, so first I am going to take question from the network theory. Okay, so first I am going to take question from the network theory. So here 5 question is asked from the network theory. Okay, so first question I am going to start. So first question is from the locus diagram. First question is from the locus diagram. So here first I am going to take question from the network theory. Okay, and this is your question number 1. And the topic name is, you can say, locus diagram. So here one resistor was given, and here one resistor and with parallel capacitor. Okay, this circuit is given. This circuit is basically given here, and here this is nothing but impedance is Z of j omega. This resistance value is R1, this resistance value is R2, and this capacitor value is C here. This capacitor value is given C. And just I am going to read out the question. For the circuit shown, the locus of the impedance Z j omega is plotted. So here locus of this Z j omega is given. So locus of Z of j omega is given, and we know very well what do you mean by locus. Locus means real axis. Here to assume here real part of Z j omega and imaginary axis, imaginary part of, you can say imaginary axis is imaginary part of Z of j omega. So here this axis is given, x axis, and this is y axis. So we can say here in x axis, okay, here in x axis this is real part of Z, you can say this is real part of Z, and this is imaginary part of Z, is given. And here locus is also given, and locus is from this is from 2 to 5, this is from 2 to 5 given. This value is 0, this value is 1, here this is 3, here this is 4, and here this is 5, and this value is going to start at omega is equal to 0, and here this omega is moving in this direction, and this value we are getting at omega is equal to infinite. So this locus was given, and here the resistance value in kilo ohm, given in kilo ohm. This was the exact question, and here the value of R1 and R2 we have to calculate. So in this question value of R1 and R2, so value of R1 and R2 is 4 options they have provided here. So first option is given, R1 is 2 kilo ohm, R2 is 5 kilo ohm. R1 is 2 kilo ohm, R2 is given, this is 5 kilo ohm. Similarly option B is given here, R1 is 5 kilo ohm and R2 is given here, this is 2.5 kilo ohm, and third option is given here, this is R1 is 2 kilo ohm, and R2 is given 3 kilo ohm, this is 3 kilo ohm. And similarly the last option option D is given, R1 is 5 kilo ohm and R2 is given, this is your 2 kilo ohm. So here R1 and R2 we have to calculate. So easily you can find out. First you have to find out here Z of j omega. So first we have to find out here Z of j omega. So how we can handle this question? So can I write this in the form of impedance? So you can write this is 1 by CS, this is R2. So what will be the Z of S? So Z of S is nothing but this R1 is series with R2 and capacitor. So this I can write R1 plus R2 and parallel with this. So R2 into 1 by CS divided by R2 plus 1 by CS. So from here we will get the CS and CS will be cancelled out. So we will get R1 plus this is R2CS. So here you will get R2 divided by here 1 plus R2 into C into S, and this is your ZS. So what will be here? What will be here? Z of J omega. What will be here? Z of J omega. So this is nothing but R1 plus R2 divided by 1 plus R2 into C, and this is, you can say, write, this is multiplied by S, you can write J omega. Okay, so we have to find out here value. One time we have to calculate for omega is equal to 0, and one time we have to calculate at omega is equal to infinite. So if first value, if we find out sir Z 0, so here first either you can calculate real part and imaginary part, and you can also try directly, you can put value here. So sir, for omega is equal to 0, for this omega is equal to 0, already you know the answer, only real part you will get. So you can put here, if omega is equal to 0, so this whole term will be 0. So here you are directly you are getting sir R1 plus R2, and this value already here given at omega is equal to 0, this only real part you are getting, and that value is 5. So here you are getting real part, and this value is nothing but 5 ohm. So R1 plus R2 is 5 ohm. So first equation we have find it out. Now similarly sir, Z of J infinite. So can we calculate? So if this is infinite plus 0 infinite, R2 by infinite is 0. So from here you will get directly R1. So calculation time we have to save here. So here, and this value is given, and this is nothing but 2 ohm. So R1 already we have calculated, this is not 2 ohm, this is given in kilo ohm. This is given in kilo ohm. Okay, so this is not ohm, this is not ohm, this is kilo ohm. So here this is 5 kilo ohm, and here this is 2 kilo ohm. So what will be the R2? 5 kilo minus R1. So what will be the here R2? So R2 we are getting, this is 5 kilo minus R2. So this is 5 kilo ohm minus of R2, and R2 minus of this is R2 minus of R1, and R1 already we have calculated, so 5 kilo ohm minus of 2, so we are getting here, this is nothing but 3 kilo ohm, so R2 is 3 kilo ohm and R1 is 2 kilo. This was very easier question. Some student will do here, they will separate real part and imaginary part, and after that they will put the value, but this time at least we have to save. So the answer is, this is 3 kilo ohm and 5 kilo ohm, 2 kilo ohm and 3 kilo ohm. So R1 is 2 kilo ohm and R2 is 3 kilo ohm. So option C is the answer. So I hope this was a very easier question, and anybody can handle this question is GATE exam. Okay, and this is 2 marks MCQ. So this question is for 2 marks. This question is for 2 marks, not 1 marks. So this question is for 2 marks. So definitely you have definitely corrected. I hope definitely you have corrected this question in GATE exam. Okay, so just confirm me. Have you correctly attempted or not this question? Okay, please comment me everyone. So now I am going to take second question. So second question from network theory, question number 2, and this question is again 2 marks. Again this question is 2 mark question. So in this question, one supply voltage, and this voltage is Vt, and Vt is given, this is nothing but sin t. So your magnitude is 1 and frequency omega is also 1 radian per second, and this is connected with one load, and this load is Z, and now this current is given, I of t, and here this current waveform is given. So the current waveform is given here in this way. So actually this question representation is different here. So maybe some student can be trapped in this question. Okay, so but you should here at least approximate what exactly examiner want to say. So here x-axis they have not provided in the question. In this question they have not provided exactly x-axis. Okay, this is your 0 axis, and this is your 0 axis, and now here one sine waveform they have provided in this way. They have provided one sine waveform in this way, and just they have mentioned here, this is your t is equal to pi by 4. this is equal to T is equal to pi by 4, and now this magnitude they have also mentioned, this maximum and this minimum amplitude they have mentioned, this is 1 by root 2, and this is current, so this is ampere, and this is minus of 1 by root 2, this is ampere. You can say this is nothing but a 0 ampere. Okay, and now this x axis is nothing but, this is nothing but time. So this thing is given. So this was the question. Voltage sign is given and current is given, and now what they are asking, the element Z is. So in this question, the question was element Z is. So examiner have asked element Z is. So if you are expert in network theory, so how you can handle this question in GATE exam? So first I am going to write here 4 options. So in first options, a capacitor is equal to 1 farad. Second option B was given here, an inductor is equal to, this is root over 3 Henry, and option C is given again, capacitor is equal to root over 3 farad, and option D is given here, inductor is equal to 1 Henry. So here these 4 options was given. So now you can see this point is exactly here voltage. You can say, sir, this is voltage amplitude is 1 volt, and what is omega here? Sir, omega is 1 radian per second. So here omega is 1 radian per second, and now in result what you are getting, you can also write this IT. How you can write this IT? Sir, this IT easily I can write this IT amplitude, maximum amplitude is 1 upon root 2, and we can write this in the form of sine. So this is sine omega t, and here omega is 1, so I can write sine t. But the important thing is, now this is not, you can say this is not at a 0, t is equal to 0, this is shifted. So just they have mentioned this is a pi by 4 shifted version of sine. So this is a pi by 4 shifted version of time, and positive or negative, positive shifted. So this is a delayed version of this sine. So I can write, sir, t plus pi by 4. So you can write this t plus pi by 4. So you can write this is okay. So don't write here t minus pi by 4. Here this is sine t plus pi by 4. Here this is sine t plus pi by 4. So this value was initially 0, and now this value was here pi by 4. So now you can see here, voltage is sine t, and current is leading here. Current is, you can say, leading here. Current angle is more than voltage angle. So here if current is leading, so directly we can say here the answer will be capacitor, because in capacitor current will be leading. So either answer will be this capacitor, either this capacitor or this capacitor, but here the magnitude is 1 by root 2. It means what should be the magnitude of this Z and what should be the angle of this Z. So this Z you can write, sir, magnitude of Z, and this is angle of Z. So magnitude of Z will be here nothing but this, you can say here, sir, this magnitude of Z is nothing but 1 by root 2, and sir, what is the angle of this Z? Angle of Z will be here 180 by 4. You can say, sir, this is 45 degree. So impedance 1 upon root 2. So here impedance 1 upon root 2 at angle 45 degree. Okay, this is required? No, this is your transfer function. This is your output by input ratio. This is your output of input ratio. Sir, what should be the Z? So here Z you can write, sir, Z will be minus 45 degree or plus 45 degree. Sometimes student can be wrong here. So now just I want to explain you this in very different form. Okay, just I am going to remove this part. So how you can handle this question? Already in network analysis many times we have to discuss this category of question. So you can see here, this is a input signal, this is a sine t, and here output signal is, sir, what is required? 1 by root 2, this is sine t plus pi by 4, this is required, and sir, this is one system, you can see. So sir, magnitude of this system at omega is equal to 1. So magnitude of this system at omega is equal to 1 should be 1 by root 2, and angle of this system at omega is equal to 1 should be plus 45 degree. And now sir, what will be here? HS, output by input. Here output is current, here output is current, and sir input is a voltage. So what you can write here, sir? HS is nothing but output is current, so current by voltage. So you can say this is nothing but 1 by Z. This is nothing but 1 by Z. So 1 by Z. This is nothing but 1 by Z. So here just they are asking what will be the Z? What will be the impedance Z? So examiner are asking, sir, what will be the exactly here Z? So this system is required, and you can say this system is required, and this system will give you amplitude 1 by root 2 multiply, and angle will be shifted pi by 4. Angle will be shifted pi by 4. So how you can calculate this? How you can calculate this? So this system is required, and this system amplitude will be 1 by root 2. The system amplitude will be 1 by root 2, this system amplitude, and sir this angle will be plus 45 degrees. So I can write, sir, mod of h j omega, I can write this is j1 is equal to 1 by root 2, and here sir angle of h j1, omega is 1, this should be is equal to 45 degree, and this is nothing but 1 by z. So you can write here, sir, here z will be, so can I write here, then sir impedance will be root 2 at angle minus of 45 degree. So impedance will be root 2 at angle minus of 45 degree. Impedance will be root 2 at angle minus of 45 degree. So you can see from here the resistor is given. You can say here okay, one mistakes actually we did here. Okay, now here one resistor was also connected, here one resistor was also connected, and this is 1 ohm, and this resistor value is 1 ohm. Okay, then this will be inductor or capacitor. Okay, then what will be the Z? So suppose if resistor is 1 ohm, and suppose I am considering first option, so sir this is 1 plus this is Z, sorry, for the capacitor if I want to write, so this will be minus, sir, J by omega C. Omega is 1 and C is 1, so you are getting here 1 minus C. So what will be the Z? Magnitude of Z is nothing but, sir, I can write root 2, and what is angle of Z for this? This is tan inverse 1 by 1 minus 1 by 1, sir, this is minus of 45 degree. So you are getting the same answer. You are getting the same answer, but you don't have to check all the 4 options. Just you have to check, because impedance you are getting negative. Impedance you are getting negative. In another way you can say current is leading. So if current is leading or impedance is negative, so definitely answer will be capacitor. So either answer will be this or answer will be this. So if you will assume this one, so what will be the Z? So sir, Z will be, this is 1 minus J by omega C. Omega is 1, so divide by root 3. And now this magnitude you will not get root 2, and this angle you will not get minus 45 degree. So basically this question you have to handle from the topic when sinusoidal signal is passed from a system. So this basic easily you can apply here. Okay, so this type of question already I have discussed in my last network analysis session in global channel. Okay, so many of, I hope you have seen how we can handle this category of question. Okay, so now okay, yeah, Chandani sir will not take because today's session is for electronic students. Okay, now the next question, question number 3. Okay, so in the previous question, what was our exact answer? Okay, in the previous question, what was our exact answer? Our answer was this capacitor of 1 farad. Capacitor of 1 farad. So here, if you will get, or in this diagram, if suppose this is a capacitor, so this was your circuit, so this is resistor, this is your capacitor. Here you are getting voltage, this voltage is given, sir, this is 1 ohm, and this is directly, if I want to write impedance, this is sin t, this voltage is sin t, this is voltage, and here current you have to calculate, and sir this capacitor value is minus J by omega C. So just I can write, sir, minus J, this is an ohm and this is an ohm, so this is 1 minus J. So if you will solve this, so what answer you will get? This current you will get. Okay, so this question was easier question. Now the next question, question number 3. Okay, but sometime some student can be trapped in this question, because what exactly examiner want to say here. Okay, now in the next question number 3, from the network theory, Question number 3 from the network theory. One linear network is given. So here one linear network is given. One linear network is given, and here the supply voltage is given. This supply voltage, and the supply voltage is given 10 volt. This current is given I1. This is a 2-port network, you can say, and this voltage is given V1. One thing you remember, in question they have mentioned this is a linear network. This is a linear network, and now here one more variable resistor is connected. This variable resistor is connected, and I2 direction is incoming. This is very important. This I2 direction is incoming, and here voltage is given. This voltage is V2, and this was figure number A. This is figure number A, and one more figure was given. This V2 I2 characteristic, this is your minus of I2, because this I2 direction is opposite. So always current across this resistor you will get negative value. That's why they have considered minus I2. Okay, you can also write in this direction. You can also write this current if Ix. So you can also write, sir, this can be Ix. But in question they have not written Ix. They have mentioned minus of I2. And now the value is given. Here this is 4 milliampere, and here voltage is going to be drop. Voltage is going to be drop from 5 volt to 4 volt. 5 volt to 4 volt when current is 4 milliampere. This is figure number B. This is figure number B. Figure number B. And one more figure they have provided. And in the third figure, one resistor and one voltage source. One resistor and one voltage source is given. This voltage source is 10 volt. This resistor was given 1 kilo ohm. And this is figure number C. Okay, so just I want to tell you what was the exactly question. So I am going to read out. AR is where is the measured voltage and current at port 2 is shown in the figure B, and this voltage VI characteristic is given for V2 and minus I2. Okay, now here some condition is given by the examiner. So first condition they have mentioned, if V2 is equal to 4 volt. If V2 is equal to 4 volt, okay, in this time, sorry, if V2 is equal to 4 volt, okay, in this time I2 is equal to minus 4 ampere, and one more condition, second condition also they have provided, V2 is equal to 5 volt. If V2 is equal to 5 volt, in that time, sir, I2 is equal to 0 ampere. So these two conditions they have provided, and now what they are asking, if this R is replaced by figure C. So now the question is, now what is the question? If this R variable resistor is replaced by figure C, by figure C. So figure C circuit is resistor with voltage source, or you can say with one battery. So if R is replaced by figure C, then the value of, then they are asking, then the value of I2 is, so here I2 we have to calculate, so 4 options in this question. Okay, no, again maybe this is a numerical answer type, NAT type question. So again this is very easier question. So two condition is given. So if in any question two condition is given, so first you have to apply both the condition in the circuit, and just you can handle this kind of question easily by Thevenin theorem. So what we can do, you can remove this part, and this whole part is replaced by Thevenin equivalent network. Why you can replace? Because you can say, sir, this network is a linear network, so easily this network you can replace by, sir, this is a Thevenin voltage and this is a Thevenin resistance. So can I replace? Yes. So this is Thevenin voltage and Thevenin resistance, and now both the condition you can apply. So first I am applying this condition. If I2 is 0 ampere means open circuited, so in this time this voltage you are getting here, this V2, and V2 is nothing but 5 volt. And can I say here current will be 0 ampere. So this 5 volt be equal to VTH. So here VTH you have calculated. So here VTH we have calculated. Now the second condition, if we will apply the second condition, so you can see here, now VTH we have calculated, just I can put the 5 volt, and now RTH we have to calculate from the second condition. So from the second condition, we have to calculate RTH. So in second condition, sir, if V2 is 5 volt and I2 is minus 4 ampere, means opposite direction. So if V2 is this 4 volt, then this current is minus 4. So this current is 4 ampere. It means what was the resistor? It means in this situation, what was the resistor? Resistor was 1 ohm. So here in this condition, you can say, sir, this resistor value is 1 ohm. And in this condition, current is open circuited. So here you can say, sir, R is infinite ohm. So here R is infinite ohm. R is infinite means open circuited. So now here you can connect, sir, this is 1 ohm resistor. This is 5 volt. This is 1 ohm resistor. This is 1 ohm resistor. So now from here, RTH easily we can calculate. So now here voltage is given. This voltage was 4 volt. Now you can say, sir, if this is 5 volt, this is 4 volt. So what will be the drop here? 1 volt. So what will be the drop here? 1 volt. And what was the current? In this direction, current was 4 milliampere. So here what will be the resistance value? So RTH can I write voltage? Voltage is 1 volt divided by, sir, current is 4 milliampere. This is 1 volt divided by 4 milliampere. So 1 by 4, 0.25. Sir, this is 0.25 kilo ohm. Milli, you can write in kilo ohm. So RTH and VTH easily you can calculate for this network. So now come to the question. This part you have to connect at the load. Now this part you have to connect at the load. So this is VTH. This is VTH, this is RTH, this is RTH. RTH is 0.25 kilo ohm. And what was the VTH? VTH is 5 volt. And now this part, if I am going to connect here, this part I am going to connect here. This is 1 kilo ohm. And here this is 10 volt. Here this is 10 volt. And here I2 you have to calculate. So now the first thing, I2 will be positive or I2 will be negative. So here some student may be wrong with the direction. So here you have to concentrate on the direction. So what I can say is the I2 will be positive. So what will be the I2? So I2 you can write, sir, 10 minus 5. This is 10 minus 5 divided by, this is 1.25. This is 1.25 kilo. So here the answer is 5 by 1.25 kilo. So here answer will be 5 by 1.25, 4 milliampere. The answer is 4 milliampere. The answer is 4 milliampere. So this is numerical answer type question. This is numerical answer type question. Okay. And here they have asked answer in milliampere. So what you have to put here? The answer will be 4. The answer will be 4. Again, this is the easier question. So by Thevenin theorem, easily we can handle this question. And two more question, and that was very easier question is asked. Okay, so question number 4. Now the next question I am going to take. Question number 4 from the network theory. So next question I am going to take. Next question I am going to take, that is question number 4. Okay, next question is question number 4. Okay, question number 4. So in question number 4, one network is given. This network is given. Here one supply voltage, one resistor, here one more resistor, and here one more resistor, and one current source, is given. Okay, this network was given. All the resistance is 2 kilo ohm. This is 2 kilo ohm, and this is 2 kilo ohm. The supply voltage is 5 volt. The supply voltage is 5 volt, and this current was 10 raised to power minus 3 ampere. 10 raised to power minus 3 ampere. And now in this question, this current we have to calculate. We have to calculate this current I. So I is equal to question mark. I is equal to question mark. So 4 options. Here this is a multiple choice question. Okay. So here this is MCQ. The question was MCQ. So 4 options I am going to write. Sir, 1.16 into 10 raised to power minus 3 ampere. Minus 3 means milliampere you can say. The option B is 0.75 into 10 raised to power minus 3 ampere. Option C is minus of 0.5 into 10 raised to power minus 3 ampere. And option D is 1.25 into 10 raised to power minus 3 ampere. 4 options they have provided. So by easily KCL, KVL we can handle this question. How we can handle this question? So you can see here, this current is 10 raised to power minus 3 ampere. So can I write here nodal? So you can assume this as a ground. Suppose I am going to assume this voltage as a V, and I am going to write here KCL. So what we will get here? Sir, V minus 5 divided by, this is 2 kilo. plus this is V minus 0 divided by 2 kilo, and this incoming current I can write is equal to 10 raised to power minus 3. So can I multiply here 2k? If I will multiply in numerator by 2k, so we will get V minus 5 plus V is equal to, here kilo and 10 to the minus 3 will be cancelled out, you will get 2. So V plus V, this is 2V is equal to 5 plus 2 7. So V is equal to 7 by 2 3.5 volt. So what we are getting 3.5 volt. So sir, what will be this current? So 5 minus 3.5. So what will be I is 5 minus of V divided by this resistance is 2 kilo. So what will be the answer? 5 minus 3.5. This is 1.5 divided by 2 kilo. 1.5 divided by 2 into 10 raised to power minus 3. So answer is 0.75 into 10 raised to power minus 3 ampere. Because answer examiner ask in ampere. Okay, they should also provide a milli ampere. Okay, so here answer is option B. So here answer is option B. Here answer is option B. Again, this was very easier question. Any student can handle this question, I think, within 60 seconds. So till now we have discussed 4 number of question from the network theory. Yeah, initial first question was easier. So in second question you have to do some calculation. In third question also you have to do some calculation. This was very easier and very basic question. Now one last question from the network theory. One last question from the network theory. So now the question is, next question is question number 5. Question number 5. So in question number 5, this was very basic question. Pen is not required. Directly within 10 seconds, any student can handle this question. Okay, any student can handle this question. Okay, okay. Now, sir, Vijay, you are asking, sir, 69 marks. Yeah, 69 marks is perfect. Okay, 69 marks is not more good. You can say more than good. Okay, so definitely you will get a good rank. Okay, now. Okay, so Gaurav, you are saying, sir, in previous question, sir, T was pi by 4. That is a shifted version of sinusoidal. That is a shifted version of sinusoidal. Okay, so last question just I am going to take, and this is a very, very basic question. So here one battery is given of 3 volt. Here one resistance is given. Here one more resistance is given like this. This is your given 2 ohm, and this resistance is given 1 ohm. And here one resistance is connected, and this resistance value is 10 ohm. And now again here one resistance is given, one more resistance was given, and here again one battery was connected. This was the circuit, and now this volt value is a resistance 2 ohm. This is 2 ohm, and this one is 3 volt. And now current, this current across 10 ohm we have to calculate in this question. This is very, very basic question. Sir, what will be the I is equal to question mark? Sir, what will be the I is equal to question mark? So I hope this was a very, very easier question, and any student can directly handle within 5 seconds this question. Only this is a single path, so no current will flow from here. All these are connected in series. All these are connected in series. Here how much current will flow? So here current will be 0 ampere. So what will be the answer here? I will be equal to 0 ampere. So what will be the answer here? I will be 0 ampere. So easily anybody can see this answer directly. Okay, I hope within 5-10 seconds anybody can put answer for this question. This is 0 ampere. Okay, so 5 questions from the network theory, and according to me, if you are a good student or if you are also a average student, so I hope all the question, all the 5 question, according to me, okay, definitely correctly you have attempted. Okay, sir, your current equation is not following. Current equation, why current equation is? Okay, in previous question current equation, no, current equation will be here. They have said, suppose in previous question, if I will discuss in the previous question. Okay, now come to here. Okay, this was question. They have mentioned this. Okay, so here you can say in generally this was the sin 0, but here they have mentioned t is equal to pi by 4, means this is a shifted version. So here you can say it can be either advanced or it can be delayed. So it can be anything. It can be plus pi by 4, means shifted version, or it can be advanced. But I have assumed here the output of the signal is 1 by root 2 sine of t plus pi by 4. Maybe it can be t minus pi by 4. because I said this diagram clearly they have not mentioned, but according to me our answer is correct. Suppose if this is a t minus pi by 4, so in this case your answer will be, if this is t minus pi by 4, so if t minus pi by 4, it means your amplitude is same, your angle will be here positive, so your answer will be, sir, inductor 1 Henry. Inductor 1 Henry. So there are some complications, but maybe this diagram is clearly for sin t plus pi by 4. Okay, so let's hope this answer will be correct, and we can wait for the answer key that is given by the IIT. Okay, now I hope this 5 question is clear to all of you. Okay, and now I am going to start. Okay, now I am going to start question from digital electronics. Okay, now I am going to start question from digital electronics. So in digital electronics, okay, 5 number of question has been asked, and all the 5 question was very easier, you can say. Okay, so all the 5 question was easier. So first question I am going to take. Okay, here one question asked from the ADC DAC. You can say the first question is from digital to analog converter. Second question is from, you can say, state transition diagram. Third question is from logic gate, and one question from the 2-bit counter and JK flip-flop, you can say sequential circuit, and one question from the multiplexer. So 5 question has been asked from the digital electronics. No question is asked from the computer organization. So from CO 0 question, and all the topic they have touched, total 5 number of question is asked. Okay, so now, so first question I am going to take here. So first question from the digital electronics. So first question from the digital electronics. Okay, first question from the digital electronics. Okay, so here I am going to take first question from digital to analog converter. So this op-amp was given, this is plus, this is minus, this is your output voltage. This output voltage is V0. Here one feedback resistance was given. This feedback resistance was 3 kilo. This feedback resistance was 3R. This feedback resistance was 3R. Here this was one resistor, and this is 2R. This resistor was 2R. Again here this resistance is 2R. Here this resistance is R. This is standard R to R ladder circuit. Again this is 2R. Again here this is R. Again here this is 2R. Again here this is 2R. Okay, now again here this is R, and this is 2R, and one more 2R, and this is ground. This is ground. Here supply voltage is given. This was again ground. Here supply voltage is given. Again this was ground, and this non-inverting terminal is connected with the ground. Okay, so this was the exact question. Here this is 2R, and here this is R, and now this supply voltage is given. This is plus 1.6 volt, and this was again plus 1.6 volt, plus 1.6 volt. Okay, and we have to calculate here V0. Again this is a 2 mark question. This is a 2 mark question, and this is, you can say, maybe this is a NAT category of question. What will be the V0 here? What will be the V0 here? How we can handle this question? You can handle this question either by network theory, Thevenin theorem, either by analog electronics, by anything. So you can say this is digital electronics, analog circuits, and network theory. You can mix here. Okay, so now how you can handle this question? First this part. Okay, this part, or you can say from here this part, you have to calculate from the Thevenin theorem, and I hope a DAC, this is standard DAC circuit, R to R ladder network, so directly we can handle. So first you have to replace this part. First you have to replace this part in this way. This is plus minus. Here this resistance was 2R. Here this feedback resistance was 3R. This feedback resistance was 3R. This V0 you have to calculate. This is connected with ground. Here one resistor and one voltage VTH. This voltage VTH. So first you have to replace this circuit in this way. And now sir, what is this resistor? So all the supply will be 0. So 2R, 2R, RR, 2R, 2R, 2R parallel R, then RR series 2R, then 2R, 2R parallel R, then RR in series 2R, then 2R, 2R parallel R. So here you will get this is R. This standard R2R ladder network. Now if you will calculate for this plus 1.6 volt, so what you will get? Here this is divided by 2. Here this is divided by 2, divided by 4, divided by 8, divided by 16. So can I write directly answer for this 1.6 volt? Here you will get VTH1 and for this you will get VTH2. So here this VTH you can write, sir, we will get VTH1 plus VTH2. So you can apply here superposition theorem from the network theory. Sir, VTH1 you will get 1.6 divided by 2 divided by 4 divided by 8 divided by 16. Directly you can write. So this you are getting, sir, 1.6 divided by 16 plus this is 0.1, and here sir, here this is 1.6 divided by 2 divided by 4. So this you are getting 1.6 divided by 4. So what value you will get here from? Sir, this is 0.1 and this is 0.4. So what will be the complete VTH? You are getting 0.5, and this you can say, sir, R plus 2R is 3R, and this is 3R. So feedback resistance is 3R. So directly you can write V0. V0 is negative of this is 3R by 3R minus of 3R by 3R into VTH, and VTH is 0.5 volt. 0.5 volt. So this 3R will be cancelled out. So output voltage will be minus of 0.5 volt. So this was the exact answer. So this is a numerical answer type question, and here the important thing, your answer is negative. Here your answer is negative. Here your answer is negative. Okay, so according to me, this question easily we can handle in 1 to 1.5 minutes. Okay, this was easier question. Okay, already in every class every teacher will handle. Some teacher will discuss sometime in network theory, in analog circuit, and digital. Already I have also discussed. Okay, so now the second question. Now the second question. Question number 2. Question number 2. Question number 2 is given here. Question number 2, and the question number is 2 is from state transition diagram, and this is a best question from the digital electronics. Okay, so in this question 3 state was given. This is state A, this is state B, this is state B, and one more state is given. This is state C. So 3 state is given, and probability is given here. Some probability is given here. So when moving from state A to state B, this probability given is P1, and this probability is given P1. And now from B to B, this probability is given P2. And now from B to A, this probability is given P3. This probability is given P3. Now P4, from A to C, this probability is given. This probability is given P4. And now C to C probability is given. This probability is given P5. And now C to A. This probability is given P6. And now from A to A, this probability is given P7. Okay, so now from all the states, probability is given. So now examiner asking for this state diagram, which is are universally true. This is first MSQ question. This is MSQ question, and this is 2 marks. This is MSQ question and 2 marks MSQ question. So 4 options I am going to provide you. Here what is the exact question? So for this state diagram, okay, which is slash R, because this is a MSQ question, which is R universally true. Universally true. So which one is the true here? 4 options they have provided. 4 options they have provided here. 4 options. So first option I am going to write. First option is here. Okay. First option is here. P2 plus P4 plus P7. P2 plus P4 plus P7 is equal to 1. Second option is P1 plus P4 plus P7 is equal to 1. And in the third option, P1 plus P3 is equal to P4 plus P6. This was the third option, and now the last option was P2 plus P3 is equal to P5 plus P6. Okay, these four options is given here. So how you can handle this question? Again, according to me, this is the easier question. So you can see, if you are at state A, so only you have three choices. Either you will come to same state, either you will move to state B, or you will move to state C. So here this is, you can say P7, and this is P1, and this is P4. So only you have three choices. So can I write here P1 plus P4 plus P7 will be definitely is equal to 1. So from A to B this is P1, from A to C this is P4, and from A to A this is P7. So all the possibility from the moving from the state A. So can I write, sir, P1 plus P4 plus P7 is equal to 1. Similarly, for B I can also write either you will come to B and this is P2. This is the first condition. Okay, so second condition I can write for the state B, sir, this is P2 plus, and now either you will move from B to A, and this probability is P3. So P2 plus P3 will be again 1. And now, sir, what is the third condition? Third condition for the C, either you will be back to C, this is P5, either you will move to A. So P5 plus P6 will be 1. So P5 plus this is P6 will be equal to 1. So three equations you are getting. This is first, this is number 2, this is number 3. So three equations you will get. So now you can see the option. You can see the option here. Now you can see the option here. P1 plus P4 plus P7 will be equal to 1. So this will be definitely correct. This is the first choice. This is MSQ question. Now, sir, P2 plus P3 is 1. Here you can say, sir, P2 plus P3, and this value is 1. And P5 plus P6 is always is also equal to 1. So from here, so this is equal to this will satisfy us. So again this will be the correct. This will be the correct. Now, sir, P2 plus P4 plus P7 is equal to 1. No, this condition cannot be true. Now, sir, P1 plus P3 is equal to P4 plus P6. Again this condition will not be true. So here this was wrong, this was wrong. So in MSQ, here option B and option D is the correct answer. Now, one important thing also I want to tell you. Suppose if you will check, sir, P2 plus P4 plus P7. So where is P4 and P7? So P4 is this one, means you are moving from A. Okay. So what is P7? You are moving to B. Okay. So but what is P2? But P2 is B to B. So there are no any relation here. So there are no any relation. So this is a dummy value. This is totally a dummy value. Now, sir, what is P1 plus P3? So P1 plus P3 is this is P1. So P1 plus P3, you are moving from A to B and from B to A. You are moving from A to B and B to A. Okay, now, and what is P5 and P6? P5 and P6. So P5 is you are moving from C to here and you are moving from here. So P5 plus P6 already you have calculated. So this value is 1. But this P1 plus P3 this can be anything. This can be anything. One more important point I can say here. Sir, all the probability are equal probable or unequal probability. So definitely it can be anything. That's why examiner have provided this is universally true. Universally true means always true. Always true. So this was easier question. According to me, any student can handle this question in GATE exam, but this was MSQ and this will be for 2 marks. This will be for 2 marks. Okay, so please just confirm me, everyone. Just confirm me, have you attempted this question or not? Either correctly or wrong. Have you attempted or not? And if you have correctly attempted, please mention, yes sir, I have correctly attempted. Or if you only attempted, so just mention, sir, I attempted only. Please tell me everyone. So now I am going to take another question. So three more question from the digital electronics. Okay, so now the next question. Question number 3. Next question number 3. Okay, so in third question, and this is question is from again MSQ and 2 marks. So again this is MSQ and again this is 2 marks. Again this is 2 marks, and this question is from the logic gate. So here one gate is provided and this logic function is a plus b bar, and this logic function is a plus b bar. So you can write, sir, this gate is nothing but like this. This gate is nothing but like this. Okay, so here they have provided one gate and this is nothing but Y. So this is nothing but Y. So this gate is given, and now here they have also provided 0 and 1 is also available. 0 and 1 is also available. 0 and 1 is also available. So here 4 options they have provided. Okay, so which logic gate can be implemented by this? So the question was which logic gate can or cannot be implemented by this. This line I am writing from myself. Examiner have not mentioned this line, just I am going to write for you. So which logic gate can or cannot be implemented by this. So if you can see, already we have studied, already I have tell you in my classes, sir, this is a universal logic gate. In general we have 4 universal logic gate: NAND gate, NOR gate, and this name generally I call global 1 and global 2. So total number of 4 universal logic gate. So first universal logic gate. So we know very well, sir, first universal logic gate is NAND. NAND you can say, sir, A dot B whole bar. Sir, second one is NOR. This is nothing but A plus B whole bar. Sir, third logic gate, you can say any name. So I can write, sir, A plus B bar. And fourth logic gate, sir, A dot B bar. This is A dot B bar. All these 4 are universal logic gate. So this is universal logic gate. It means any logic gate you can implement by this. So now we can check the option. So in first option they have mentioned, in first option, and logic cannot be implemented. And logic cannot be implemented. Option B is given here, or logic cannot be implemented. Now option C is given, NAND logic can be implemented. And the fourth option number D, sir, NOR logic can be implemented. Okay, so they have not mentioned this line. Okay, so they have asked which statement is true. So here the question was which statement is true. Okay, so just I have written this statement so that at least you can think what was the exactly question. So in this question, 4 statements they have provided and they are asking which statement is true. So you can see, sir, this is a universal logic gate. It means any logic gate we can implement by this, any logic gate. So sir, and yes, we can implement, but in the question you can see they have mentioned and logic cannot be implemented. It means this statement is wrong. This statement is wrong because and we can implement. Now sir, OR logic cannot be implemented. We can implement OR logic. So again this will be wrong. Sir, NAND logic can be implemented. Yes, NAND you can implement. Sir, NOR can we implement? Yes, NOR we can implement. All the logic that we can implement. But here 2 options they have provided cannot. That's why this 2 option was wrong. And C and D, this option was correct. Actual they have given option. This was A, this was B, this was C, this was D. So in actual gate exam, they have mentioned this was option A, this was option B, this was option C, and this was option D. Okay, so first can, cannot, cannot. Like this 4 options they have provided. So for NAND and NOR, this can option can be correct and cannot will be the wrong. So this is a MSQ 2 marks. According to me, this is very easier question. According to me, this is very easier question. Okay, so now this was question number 3rd, and the 2 more question has been asked from the digital electronics. Okay, so next question number 4 I am going to take. Question number 4. Okay, question number 4. So here this is question number 4, and this was easiest question in the electronics gate 2022. Easiest question. So just they have provided one multiplexer. This is one multiplexer. Here these 2 are the selections line. One S1 and S0. Now this value is C and D. This value is C and D, and this is 4 input. So this is 4 cross 1 mux. This is a 4 cross 1 mux, and the input voltage value is given. They have mentioned A0, A1, A2, A3. This is A0, A1, this is A2, and this is A3. You can say, sir, this is I0, I1, this is I2, and this is I3, I3, and the output is given. This output is given here. This output is given here, C XOR D. So here they have mentioned output is C XOR D, and now they are asking what is A0, what is A1, what is A2, and what is A3. So A0, A1, A2, A3 we have to find out. So you can see which min term is required here. So C XOR D, you can say, sir, C bar D plus C D bar. So which min term is required here? So you can say summation of, sir, this is 1 and 2. So 0 and 3 min term is not required, 1 and 2 is required. So can I say definitely, sir, this will be 0, this will be 1, this will be 1. So min term, you can say this is min term 0, min term 3, this is min term 1, min term 2. So min term 1 and 2 is required, and 0 and 3 is not required. You can check the answer. So what is the answer for this? C bar D bar multiply by I0, I0 means A0 means 0, plus C bar D multiply with 1, plus CD bar multiply with 1, plus CD multiply with 0. So this is 0, this is 0. So you are getting here C bar D plus CD bar. It means C XOR D. So this was easiest question, So I can say this is the easiest question. Okay, easiest question in GATE 2022. Okay, so according to me, this is a bonus mark. So this is a bonus mark, okay, and this is a bonus mark. Now the last question. Last question I am going to take from the digital electronics. Then another teacher will take your another subject sessions. Okay, so now question number 5. Question number 5 from the digital electronics. Question number 5 from the digital electronics. And this question is again a good question. So in this question, one counter is given. This is a 2-bit counter, and one flip-flop is given, Okay, so this first one is counter here. This one is counter. So this is 2-bit counter. They have not mentioned this up counter or down counter, and the same clock is connected to both the block. Same clock is connected to both the block. This is your input clock. Second block is JK flip-flop. Here this is J, here this is Q, here this is Q, here this is Q bar. So this Q we have to calculate, and J and K are connected. So now here counter input is only clock, and this counter output is 2 bit. So this one is MSB and this one is LSB, and now LSB is connected to the next one. And now what examiner have provided? Input clock frequency is F0. So input clock frequency is given F0 and 25% duty cycle. So now what they are asking, this is your output. So frequency at output. And duty cycle at output. So at output, frequency and duty cycle we have to calculate. So again you can say, sir, this is very easier question. So this output we have to find out. So initially if I will assume, suppose this is Q, suppose I am going to assume initially this Q, and also I am going to write this LSB. So just I am going to write this. So first I am going to write okay, this is initial, this is Q, and I can write here LSB. So suppose initially this was 0, this is 0 0, and output is 0. So initially this Q was 0 and LSB was 0. Now I am applying the first clock. So when you are applying the first clock, initially this was 0, this was 0 0. So when you will apply the first clock, according to this 0 0, this will no change. So after first clock, what you will get? This Q will no change. And sir, what will be this counter? Counter will count 1. So LSB will be 0 1. This data will be 0 1. So LSB will be 1. LSB will be 1. Now before applying the clock 2, you can see, sir, this input is 1, so this will be 1 1. It means in the second clock this will be toggle and this will be increase 1 step. So you can say, sir, this will be toggle, so this 0 toggle will be 1, this 0 toggle will be 1, and now this will be 1 0. So LSB will be 0 here. In this case LSB will be 0 here. Now before applying the third clock, what is your this LSB 0? It means this is 0 0. So in the next clock this will no toggle, so this will do no toggle. So if this is no toggle means this 1 will continue and this will change 1 1 and this will change 1 1. So here this will be 1, this will be 1. So now if this is 1, if this is 1, so this will be 1 1. So in the fourth clock this will be toggle, this will be toggle. So after fourth clock this will be toggle, means this will be 0, and now this LSB will be again 0. So now the data is going to be repeated. So you can say here how many states you are getting? 4 states you are getting. How many states you are getting? At output 4 states you are getting. At output 4 states you are getting. 4 states you are getting. You can say at output 0 1 1 0. So you can see then this value will be repeated. So at Q 0 1 1 0, then 0 1 1 0, then 0 1 1 0. So this value is repeat, this value will repeat, this value will repeat. So what will be the waveform at output? If I will draw waveform at output, so initially this was 0, then 0 1, then 1, then 0. Okay, this like this you will get. Then you can say 2 times 1, 2 times 0. You will get 2 times 1, 2 times 0. So your output will be 2 times 1, 2 times 0. You will get like this. You will get like this. And what will be this complete time period? What will be this complete time period? If I can say, sir, this clock time period is T0. So the output this time period is 4 times of T0. So what will be this frequency? So here this frequency will be, frequency at output will be input frequency F0 divided by 4. So if time period is more, if time period is 4 times, then frequency will be, you can say, divide by 4. So answer is here frequency at output is, so here answer is this frequency is F0 by 4. F0 by 4. And what is the duty cycle? So 4 options they have provided. This is a MCQ question. Okay, 4 options they have provided. F0 by 2 with 25% duty cycle, F0 by 4 with 25% duty cycle, F0 by 4 with 25% duty cycle, and F0 by 4 with 50% duty cycle. So frequency is F0 by 4. And what is duty cycle? You can say, sir, this is 50%. So duty cycle is here 50%. So the answer, which answer you have to take? The frequency, output frequency is F0 by 4 and duty cycle is 50%. Duty cycle is 50%. So now according to me, again this question was very easier question. So now according to me, this question was a very easier question. Now according to me, this question was a very easier question. Okay, so now my session is going to be over. Just I have discussed here 5 number of question from the network theory and 5 number of question from the digital electronics. And according to me, at least from this 10 question, if you are a good student, so I hope at least 8 question correctly you have attempted, and every student at least 6 plus question, 6 to 7 question at least every student should attempt it from here. Okay, so now the next session will start soon from the next teacher. Okay, and again I will meet with another subject, signal and system and communication system. Okay, thank you.
Okay. Hello. Hi everyone. So we are going to deal with EMT questions here. So they have given this year they have given 3 questions from EMT. So one mark question and two 2 marks questions. So total 5 marks you got here. So this year they have given very low weightage for EMT, right? Okay. So anyway, we try to solve these problems here. So this is the first question they have given. So this is the question they have given. So what is the question? Let us see. So they have given that in an electrostatic field, the electric displacement density vector d bar is given by d bar is equivalent to x cube ax cap plus y cube ay cap plus xy square az cap coulomb per meter square, where I cap, j cap and k cap are unit vectors along x axis, y axis and z axis respectively. Consider a cubical region here. So here it must be cubical, right? So consider a cubical region R which is centered at the origin with each side of length 1 meter, vertices at plus or minus 0.5 meters and plus or minus 0.5 meters, here also plus or minus 0.5 meters. That means they have given that x is varying from minus 0.5 to plus 0.5, y is varying from minus 0.5 to plus 0.5 and z value is also varying from minus 0.5 to plus 0.5. Then they are asking the electric charge enclosed within R here. So here R represents what here? R represents the cubical region, okay, whose center is at centered at what? Centered at origin, right? So they are asking us to determine the charge. They are asking us to determine the charge inside the cube here, right? Okay. So now see here. So here they have given. So I will take. So here they have given d bar. D bar is equivalent to x cube ax cap plus what? Plus y cube ay cap plus x square y az cap. X square y or xy z square? xy square az cap, right? Okay. So this is xy square az cap coulomb per meter square, right? So this is d bar they have given. So just they are asking us to determine the charge enclosed by what? Enclosed by the cubical region. So they have given some cubical region which is placed at the center of what? At the center of the origin, and here they have given x is varying from where to where here? X is varying from minus 0.5 to plus 0.5 and y value is varying from minus 0.5 to plus 0.5, right? And z value is varying from minus 0.5 to plus 0.5. So if you want to determine the charge enclosed by the cube, okay, then what you have to determine? You have to determine the electric flux that is leaving the cube. Yes or no? So how to determine the electric flux that is leaving any closed surface here? That we can determine with the help of Gauss law. So from Gauss law here, closed surface integral d bar dot dA bar is equivalent to what? Is equivalent to charge enclosed. So here the closed surface is nothing but cube, right? Okay, so the electric flux that is leaving this closed surface must be equivalent to what? Must be equivalent to charge enclosed, right? Okay, so they have given this d bar. So you have to determine this LHS term. So if you solve in this manner, it is going to be very lengthy. So that's why we are going to apply divergence theorem to this LHS side here. So I am going to apply divergence theorem. So if I apply divergence theorem to this LHS term, what I am going to get? Tell me. So I am going to get, after applying divergence theorem, I can write a closed surface integral d bar dot dA bar as what here? I can write it as triple integral. So with the help of divergence theorem, we can convert the closed surface integral into volume integral. So that is triple integral divergence of what? D bar into what? Into dV. into dV is equivalent to what? Is equivalent to charge enclosed. This is equivalent to charge enclosed. So in this manner we can represent. So if you want to determine the charge enclosed, then you have to evaluate this integration, right? Okay. So it is very simple now. So here what are the variables here? The variables are nothing but what? X, Y and Z. So here dV is nothing but dx, dy, dz, right? So what is this divergence of d bar here? So they have given d bar as what? D bar as a x cube ax cap, right, plus y cube ay cap plus xy square az cap. See, instead of writing I cap, j cap and k cap, I have written ax cap, ay cap, az cap. Okay, you can write in any manner here, it doesn't matter. So if you do the divergence of this function, divergence for this function, what you are going to get? How you have to perform the divergence here? So take this field, right, and differentiate the x component with respect to x. Then what you are going to get? If you differentiate the x component with respect to x, you are going to get 3x square. Next, differentiate the y component with respect to y. What you are going to get? 3y square. Next, differentiate the z component. This is the z component with respect to z. So if you differentiate this z component with respect to z, what you are going to get? 0. Yes or no? Okay. So this divergence of d bar is nothing but 3x square plus 3y square. So dv is nothing but dx, dy, dz. So you have to integrate with respect to what? With respect to x, y and z. So x is varying from where to where? Minus 0.5 to plus 0.5. Y is varying from minus 0.5 to plus 0.5, right? So y is varying from minus 0.5 to plus 0.5. Minus 0.5 to plus 0.5, and z is varying from minus 0.5 to plus 0.5, right? Okay. So if you perform this integration, what you are going to get? Tell me. So what you are going to get here if you perform this integration? So I am copying this. Okay. So perform this integration here. So if you perform this integration, you are going to get, so I am taking 3 outside, right? Okay. So x square dx dy dz. So if you do the integration, integral x square dx dy dz, what you are going to get? So x square dx integration is nothing but x cube by 3, integral dy is y and integral dz is z, right? So x is varying from minus 0.5 to plus 0.5, y is varying from minus 0.5 to plus 0.5 and z is also varying from minus 0.5 to plus 0.5, right? Okay. Next, what you are going to get? Next you are going to get plus. Okay. So plus plus next same thing here. So 3 into y square dx dy dz. So what is the integration of y square? You are going to get here y cube by 3 ranging from minus 0.5 to 0.5 and then x into z. Okay, this is what you are going to get if you do the integration here. Okay, it is very simple integration, you can do it, minus 0.5 to plus 0.5, right? Okay. So here what you are going to get? So solve this one and solve this one. So what you are going to get? So this is equivalent to 3 into. So here 0.5 means 1 by 2. So you can write here 1 by 3 into 1 by 2 whole cube minus of minus 1 by 2 whole cube. 1 by 2 whole cube minus of minus 1 by 2 whole cube. So what you are going to get? 1 by 8 plus 1 by 8, that is 1 by 4 here. So here you are going to get 1 by 4 and plus here the same thing, y cube by 3 So what you are going to get? 0.5 whole cube, that is 1 by 2 whole cube minus of minus 1 by 2 whole cube. So here also you are going to get 1 by 8 plus 1 by 8, that is 1 by 4. So 1 by 3 is present here, you are going to get 1 by 4. So here if you substitute, you are going to get 1. Here the range of z, if you substitute, you are going to get 1, right? So if you do this, what you are going to get? Here 3, here 3, here 3 will get cancelled. 1 by 4 plus 1 by 4 is nothing but what? 1 by 2, that is 0.5. Right? So 0.5 coulombs you are going to get. Okay. So this is nothing but what? This is nothing but charge enclosed. Yes or no? This is nothing but charge enclosed. Right? So this is what we have evaluated with the help of what? Divergence theorem. So we have converted this into what? Into triple integral divergence of d bar into dV, right? So this divergence of d bar into dV is nothing but charge enclosed. Okay, why all this here confusion? So this is the charge enclosed here, right? Okay, okay. So this is what we have determined, triple integral divergence of d bar into dV, right? So this is what we have determined. So this is nothing but what? This is nothing but charge enclosed, right? So this charge enclosed is equal to how much here? 0.5 coulombs. So this is the answer for this question, right? Okay, okay. So I hope this problem is crystal clear here. Next, we'll move on to next question. So next question, see here what they have given. So they have given that a waveguide, this is MSQ here, they have given this question is MSQ question, right? Okay, see here what they have given. A waveguide consists of two infinite parallel plates. A waveguide consists of two infinite parallel plates, which are nothing but what? They are nothing but perfect conductors at a separation of 10 power minus 4 centimeters with what? With air as dielectric. Assume the speed of light in air to be 3 into 10 to the power of 8 meters per second. Then the frequency or frequencies of TM wave which can propagate in the waveguide is R. Okay, so they have given that a waveguide consists of two infinite parallel plates. Okay, those two parallel plates are nothing but perfect conducting plates, which means they have given what here? Parallel plane waveguide. They have given here parallel plane waveguide, right? Okay, so here they have given a parallel plane waveguide. This is the waveguide they have given, right? So they have given parallel plane waveguide. Okay, okay. So the distance between these two conducting plates I am considering as A, which is equivalent to, they have given as 10 to the power of minus 4 centimeters, right? This is the data they have given, right? Okay, and inside the medium, between these perfect conducting plates, the medium is nothing but what? The medium is nothing but air medium. Okay, okay. So this is the air medium they have given, right? Okay. So they are asking what? They are asking the frequency or frequencies of TM wave which can propagate in the waveguide R. Okay, okay. So now see here. Now see here. See what is the formula for the cutoff frequency in case of what? In case of parallel plane waveguide here. The cutoff frequency formula in case of parallel plane waveguide is nothing but what? Is nothing but MC by 2A. MC by 2A, right? Okay, okay. So in parallel plane waveguide, which are the modes that are possible? In parallel plane waveguide, TE0 mode is not possible, right? So TE1 mode is possible, TE2 mode is possible, and all the higher order modes are possible, right? But here they are asking about TM mode. So in case of TM mode here, in case of TM mode, okay, TM0 mode is also possible. In case of parallel plane waveguide, TM0 mode is also possible, TM1 mode is also possible, TM2 mode is also possible. So all the higher order modes are possible. Right. So the cutoff frequency of each and every mode is going to depend upon what? Is going to depend upon this M and A values. Right. Okay. So here, since the medium between the two conducting plates is given as air medium, so I can write the cutoff frequency as what? Cutoff frequency as MC by 2A. Right. Okay. Okay. So in case of TM mode, TM0, TM1, TM2 and so on, all these frequencies are possible. Right. And this TM0 mode here, and in parallel plane waveguide, in parallel plane waveguide, this TM0 mode is called as what? Is called as TEM mode, is also called as what here? TEM mode. And this TEM mode is possible in case of what? In case of parallel plane waveguide. Remember, in case of rectangular waveguide, this mode is not possible here, whereas in case of parallel plane waveguide, this is possible. We have to keep one point in mind, that is, if you design a conducting structure with two conducting plates, so in these structures TEM mode is possible. If you design the conducting structure with if you design a waveguide with a single conducting structure like a rectangular waveguide here, if you consider rectangular waveguide, and if you consider cylindrical waveguide, so this is rectangular waveguide and this is cylindrical waveguide. In rectangular waveguide and cylindrical waveguide, TEM mode is not at all possible. TEM mode is not possible in case of rectangular waveguide and cylindrical waveguide. So here the guiding structure is constructed with what? Is constructed with a single conducting structure. So every conductor is connected to one another. Yes or no? It is designed with a single conducting structure. So here in case of rectangular waveguide and in case of cylindrical waveguide also, it is designed with a single conducting structure. So if the guiding structure is made with a single conducting structure, in those cases TEM mode is not at all possible. Whereas if the guiding structure is made with two conducting plates like this, okay, whether you can take a parallel plane waveguide or you can take our transmission lines here. So transmission lines are also nothing but what? They are also nothing but guiding structures only. Yes or no? Here it is also designed with what? Two conductors. So here also TEM mode is possible. Right? Okay. So here, since they have given parallel plane waveguide, so in parallel plane waveguide TEM mode is possible, and this TEM mode is nothing but what? Is nothing but TM0 mode. TM0 mode. Okay. So this is the least mode, or this mode is going to have the least cutoff frequency in case of what? Parallel plane waveguide. So that's why this TM0 mode or TEM mode is also called as what? Is also called as dominant mode in case of what? Parallel plane waveguide. Understood? Okay. Okay. So now see here. So that means TM0 mode means TM0 mode is possible. TM0 mode is possible means TM0 mode is possible means TM1 is also possible, TM2 is also possible, all the higher order modes are possible. Yes or no? Okay. So that means what is the cutoff frequency of this particular mode here? Is nothing but FC0. So we know that FCM cutoff frequency is equal to MC by 2A. So if you substitute M equal to 0, what you are going to get? 0 frequency. So that is 0 H. Understood? Anyway, for TM1 it is going to be greater than 0. For TM2 also it is greater than 0. So that means if the operating frequency is greater than what? Greater than the cutoff frequency of any particular mode, then that wave is going to what? Then that wave is going to propagate inside the waveguide. Wave is going to propagate inside the waveguide. Yes or no? Okay. So now what is the minimum operating frequency that is needed for the wave to propagate inside the waveguide here? So the least cutoff frequency is 0 Hz. Understood? So if the operating frequency is greater than 0 Hz, then this TM modes, all these TM modes are going to propagate inside the waveguide. Yes or no here? Okay. So that means the least frequency that is possible here is 0 Hz. So that means whatever the frequency that is greater than 0 Hz, all those frequencies are going to propagate inside the waveguide in case of what? TM mode. Okay, and here they are asking regarding what? Regarding TM mode only, right? So in case of TM mode, all frequencies are possible. All frequencies are possible in TM mode. Understood? So that means what is the answer for this question? So whatever may be the frequency that is greater than what? 0 Hz. So everything is going to be possible. So the answer for this question is all options are correct. All options are correct. Right? Okay. So this is the MSQ question they have given. This question is given for 2 marks. So if you just know the concept, then you can easily answer this question here. Right? So without having the concepts, you cannot attempt the questions in EMT. Right? Okay. So if you know these concepts, hardly it will take 1 or 2 seconds to answer this question. That's it. Right? Okay. So next. Right. So this question, so next they have given this question here. So this question, this is also given in EMT, right? So see here what they have given. So in a circuit, there is a series connection of an ideal resistor and ideal capacitor. The conduction current through resistor is, they have given as 2 into sine of t plus pi by 2 amperes, right? Then the displacement current here. So here I have forgot to represent here, then the displacement current through the capacitor is, okay. So they have given an RC circuit and they have given the conduction current through the resistor. Now they are asking us to determine the displacement current through the capacitor. Okay. So see here. So they have given RC circuit. So let us say this is R and here this is C, right? So they have applied some alternating voltage V of t across this circuit, right? Okay. So the current that is flowing through this conducting medium, that is through this resistor, is nothing but conduction current IC of t. So here whatever the current that is flowing is also nothing but what? IC of t, conduction current. Okay. So the current that is flowing between the capacitor plates is nothing but what? Is nothing but displacement current, that is ID of t, right? Okay. So now here they have given IC of t. They have given IC of t is equivalent to what? IC of t they have given as 2 into sine of what? Sine of t plus pi by 2, right? So this is the conduction current they have given, and now they are asking us what is the displacement current through the capacitor, right? Okay. So what is the displacement current through the capacitor here? How you can determine that? See here, we know that the conduction current, the expression for conduction current is nothing but what? Is nothing but double integral JC bar dot what? dA bar. In this manner I can represent. Yes or no? In terms of conduction current density, I can represent the conduction current in this manner. And the displacement current, ID is equivalent to what? Double integral ZD bar dot what? Dot dA bar. So where this ZD bar is nothing but what? ZD bar is nothing but dou D bar by dou T. Dou D bar by dou T. Yes or no here? Okay. See, from modified Ampere's law, we know that the circulation of H field around any closed loop is equivalent to what? Is equivalent to double integral JC bar plus what? Dou D bar by dou T dot what? Dot dA bar, right? So this JC bar dot dA bar is nothing but conduction current. Dou D bar dot dA bar is nothing but what? Is nothing but displacement current. Right? Okay. So I hope these things are clear, right? So now see here. Now IC equal to, so JC equal to, here JC equal to what? JC equal to sigma into E bar, right? So from here I can represent this as a sigma into double integral E bar dot what? Dot dA bar. In this manner I can represent. Yes or no? Okay. Now here id, how I can represent here id? So here dou by dou t I am taking outside the integration, right? Dou by dou t I am taking outside the integration. This d bar I am representing as epsilon into e bar, and epsilon also I am taking outside the integration. So I am writing epsilon here, right? So epsilon into dou by dou t into double integral. So what is left out here? I can write it as e bar dot what? E bar dot dA bar. What I have done here? I have taken dou by dou t outside the integration, and I have written d bar as epsilon into e bar, and I have taken epsilon also outside the operation. Okay, so then I can represent epsilon into dou by dou t into double integral e bar dot dA bar, right? Okay, now here what I am doing here is I am multiplying this with sigma and dividing with sigma, right? Multiplying with sigma and dividing with sigma. Now what you are going to get, tell me? So this term here, this term, if I consider this one, okay, double integral e bar dot dA bar into sigma, double integral e bar dot dA bar into sigma is nothing but what? I can replace it with IC. So this term I can replace with what? IC, right? Okay, so therefore I can write id as what here? Therefore I can write id is equivalent to what? id is equivalent to what? Equivalent to epsilon into dou by dou t into IC divided by sigma, right? So I am just getting the relation between IC and id here, right? So epsilon into dou IC by sigma by dou t. So this is what I am going to get. So this sigma is constant, so I can take it out of this differentiation. So I will get epsilon by sigma into what? Into dou IC of t by what? By dou t, right? So IC what they have given here? IC what they have given? They have given IC as what? They have given IC as 2 into sine of t plus pi by 2, t plus pi by 2. Okay, so if you do this, what you are going to get, tell me? So this is equivalent to epsilon by sigma. So if you differentiate this, what you are going to get? 2 multiplied by, what is the differentiation of sine function here? Is nothing but cos. So that is cos of t plus what? T plus pi by 2, right? Okay, so this is equivalent to 2 into epsilon by sigma. So cos of t plus pi by 2 is nothing but what? Is nothing but minus sine t. So the same thing I can represent as what? 2 epsilon by sigma into what? Sine of t plus pi. T plus pi. Can I represent the same thing in this manner or not? Minus sine t means I can write it as sine of t plus pi. So what you are getting here? What you are getting finally? So therefore id, therefore the displacement current id is equivalent to what? 2 into epsilon by sigma into sine of what? Sine of t plus pi amperes. So this is the answer you are going to get here. And remember here, this epsilon by sigma ratio, this epsilon by sigma ratio represents the time constant of the circuit here, time constant. Okay, so here they have given, since they have given RC circuit, so this epsilon by sigma ratio represents what? This represents time constant, which is equivalent to what? Which is equivalent to RC, right? So if you know, so I don't know whether they have given this R and C values here. Okay, so if they have given this R and C values, then you can determine this amplitude, right? Okay, so anybody remembered this R and C values here? If you know R and C values, then you can easily determine this epsilon by sigma ratio, right? Okay, so depending upon, so I can write this as 2 into what? 2 into, in place of epsilon by sigma, I can write it as what? R into C, that is the time constant, into sine of what? Sine of t plus pi amperes, right? Okay, so this is going to be id value, right? Okay, okay, so this is the answer for this question. Anybody remembered this R and C values if they have given in the examination? Tell me here. In the question they have provided R and C values or not? Tell me. Tell me here. Okay. What sir, who will touch the CMT questions? We don't remember anything. Okay, anyway, fine. Right. Okay, so this is the answer for this question, right? So if they would have given R and C values, then we can substitute those values, then you can get the expression for ID. So this is the displacement current here, right? So with this we have completed the 3 questions that they have given in case of what? In EMT, right? 3 questions we have completed now, right? So this is one question, displacement current, and waveguide question, and then Gauss law, right? So this question is based on, one question is based on Gauss law. See, they have not mentioned electrostatics, yes or no? In the syllabus they have not mentioned electrostatics, but here they have given the question of what? Question based on what? Gauss law, right? Because in the syllabus we are having Maxwell's equations, right? So Gauss law will come under what? Maxwell's equation only. So if you want to understand this Gauss law, definitely you must have some basics regarding electrostatics also, right? Okay. So anyway, we have completed all the 3 questions. I hope it is crystal clear. So now I am winding up the session with this. Next, another faculty will continue the session here. So EMT is completed, right? Next, another faculty will continue the session. So okay then, take care, bye bye.
हेलो एवरीवन, मेरी आवाज़ आ रही है? एक बार बता दीजिएगा सब लोग, आप लोग, तब तक मैं थोड़ा सा देख लूँ, यहाँ पे आपके कमेंट देख सकूँगा। ये कुछ क्वेश्चंस आए थे गेट के क्वेश्चन मॉडरेट लेवल के थे आप लोगों को। 1 मिनट। Okay, I will try to speak in English. Okay, so this one is the questions. This one is the moderate question, not that much tough question. Pre-emphasis transfer function is given and de-emphasis transfer circuit is given. So we have to analyze using this circuit. We have to keep R and C value so that the de-emphasis circuit will be designed. So this one is the pre-emphasis transfer function and this one is the de-emphasis circuit diagram, and we have to analyze R and C value so that pre-emphasis and de-emphasis circuit will work. So here omega naught is given. Omega naught is 10 to the power 4 radian per second. So first of all, we have to calculate transfer function, then after we have to relate, and then we will get the value of R and C or combination of R and C. This one is the MSQ question. Here this one is MSQ type question. We will select MSQ type question, means we will select means multiple question type, multiple choice, one A or B or C or D, anyone is correct. And in this question we will select 2 option will be correct, or 3 option will be correct, or 4 option will be correct. So we have to check all options here. Okay, so we are starting here transfer function. Transfer function, for transfer function we are getting HS. So HS is equal to 1 by CS R plus 1 by CS, and this one is HS, V naught S upon VIS, so this one is HS, so 1 by RCS plus 1, then after RCS plus 1 we will put S is equal to J omega, then we will get after that J omega RC, and RC is equal to 1 by omega naught. So cutoff, this one is the cutoff frequency you studied in the control system. So omega naught is equal to 1 by RC. So this one is the de-emphasis transfer function, 1 by J omega upon omega naught, and pre-emphasis transfer function is 1 plus J omega by omega naught. Correct? So pre-emphasis into de-emphasis is equal to 1. Pre-emphasis into de-emphasis is equal to 1. So here pre-emphasis into de-emphasis is equal to 1. So हमारा 1 होगा, that means ये omega naught and this one omega naught should be equal. Understand? This omega naught and this omega naught should be equal, because this one will become 1 only on one after that this cutoff frequency and this cutoff frequency should be equal. Then after it will be cancel out and 1 will be remaining. So the cutoff frequency of this de-emphasis circuit and pre-emphasis circuit will be same. So omega naught is equal to 1 by RC, and it is given 10 to the power 4. So by option we will check it that omega naught is given, and the omega naught is from this question will be matching or not. If it is matching, then it will be correct, or if it is not matching, it will be wrong. So we are calculating 1 by RC, and R is here 2 kilo ohm and 1 microfarad. So 2 kilo ohm and 1 microfarad. So 1 microfarad 10 to the power minus 3. It will be approximately equal to 500 radian per second. 500 radian per second. So A option will be wrong. So second option, it is simple question. Only one thing is asked, the cutoff frequency of pre-emphasis and de-emphasis should be equal. Only this thing will be asked. तो यही केवल पूछा गया है. Okay? So 1 by RC is equal to R is 1 kilo ohm and C is 1 microfarad. So 1 kilo ohm 10 to the power 3 and 0.1 microfarad 10 to the power minus 7, it is equal to 10 to the power 4 radian per second. That means B option is correct, A option is wrong. Then after we will calculate C option. C option 1 by RC is equal to 1 by RC is equal to 1 kilo ohm 10 to the power 3 and 2 microfarad 2 into 10 to the power minus 6. That means it will be 500. So C option will also be wrong. Then after we will calculate D option. D option is written D option mein. In D option 2 kilo ohm and 0.5 microfarad. So 1 by RC is equal to 1 by RC is equal to 2 kilo ohm 2 into 10 to the power 3 and 0.5 microfarad 5 into 10 to the power minus 7. So it will be 10 to the power minus 7. So it will be 1000 radian per second. We will analyze in different. So D option, for D option 1 by RC is equal to 2 kilo ohm 10 to the power 3 and 0.5 microfarad. So 5 into 10 to the power minus 7, it will be 1000 radian per second. It will be 1000 radian per second. So first option is wrong, second option is wrong, third option is also wrong, because here we are getting 500, here we are getting 10,000, here we are getting 500, and here we are getting 1000. So 10,000 is given, so B option will be correct. B option will be correct. Then after we will go through next question. This question is simply a easy or average question. In this question they are asking QPSK and 16-bit QM both are transmitting alternately. So this question is somewhat suspicious question means बोल सकते हैं. That means we can take average value. That means first of all we are transmitting QPSK, then we are transmitting 16 QM, then we are transmitting QPSK, then we are transmitting 16 QM. Like that we are transmitting the signal. Like that we are transmitting the signal. QPSK means number of signal is equal to 4 and number of bits required is equal to 2. And 16 QM means number of signal is equal to 16 and number of bits required is equal to 4. That means we are transmitting 2 bit here and 4 bit here. We are transmitting 2 bit here and 4 bit here. Like that we are transmitting. First 2 bit, second 4 bit, first 2 bit, second 4 bit. So we will take average value of number of bits. So we will take average number of bits. Why? Because here 2 bits, here 4 bits. So on an average we are transmitting 3 bits. Here 2 bits and here for 3 bits. So on an average we are transmitting 3 bits. Here 2 bits and 4 bits. So on an average we are transmitting 3 bits. So we are transmitting 3 bits on an average. 3 bits on an average. So on an average one symbol we are requiring 3 bits on an average. On an average we are requiring 3 bits. And we know that the symbol rate is equal to bit rate upon n. Bit rate upon n. So symbol rate is given here. Symbol rate is how much? 1 mega symbol per second. Symbol rate is given here 1 mega symbol per second. So bit rate is equal to n into symbol rate. So n is 3 and symbol rate is 1 mega sample per second. So we are getting 3 bits per symbol. 3 bits per symbol and 1 mega symbol yani 10 to the power 6 bits per symbol per second. So where symbol is cancelling out and we are getting 3 into 10 to the power 6 bits per second. So we are getting 3 Mbps. 3 Mbps. Question is asked in Mbps, so we will write only 3. We will write only 3. So this one is question they have asked. This one is question they have asked. Next after HX. hx and log 2k, hx 2 ka power x, hx 2x and hx x square. Here we are transmitting k bit at a time. We are we are transmitting k symbols at a time. So k symbols we are transmitting, and k symbol we are random variables, and hx. So x has how much symbol? K symbols. X has k symbols. Then after I will ask 2 ka power x has 2 ka power k symbols. 2 ka power k symbols, and 2 ka x has 8 k symbols. 2 in 2 k symbols. 2 k symbols. Then after x square. X square contribute k square symbols. That means the symbols will be changing according to random variable. Here random variable is x, so x k symbol we are generating. Here random variable is 2 ka power x, so 2 ka power x, 2 ka power k symbols we are getting, and 2x, so 2k symbols we are getting, and x square k square symbols we are getting. So simply we are getting like this. Then after we will analyze that. First of all, we are analyzing that the maximum value of entropy will be when they are equal. When they are equal, we will get maximum value of entropy. The equal probability will give maximum value of entropy. So maximum value of entropy, that means hx maximum. Hx maximum will be equal to log 2m. That means hx will be less than equal to log 2m. Less than equal to log 2m. Here, then after we analyze log 2m. Here m is k, so here hx will be equal to, here m is k, so hx will be equal to log 2 k. Here m is 2 ka power k, so hx will be equal to log 2 ka power k. Log 2 ka power k. M is 2 ka power k, so it will be k. So h 2 ka power x is equal to log 2 ka power k. H 2 ka power x is equal to log 2 ka power k. Then after 2x is equal to h 2x is equal to, so m is equal to 2k. So log 2 2k, log 2 2k, so log 2k plus log 2 2. Log 2 is 1, so log 2k plus 1. Then after hx square, here k square is there, k square symbol, so hx square is equal to less than equal to log 2 k square, that means 2 log 2k. So we are getting like this. This one is the very beautiful question. This one is tough question, not moderate question. I will not say this one is moderate question, because thinking level should be high for this question. So this entropy question is very much high level of thinking required. So we are going to think like this in the terms of k symbol, but when we are going to derive, we will say something other than this. तो derive करने के वक्त हमें कुछ दूसरा देखना पड़ता है. So first of all, hx is less than equal to log 2k. Hx is less than equals to log 2k, and hx ka power x square. Hx square is less than equal to 2 log 2k. And h 2 ka power x is equal to log 2 log k को बराबर k, and h 2x is equal to log 2k plus 1. That means hx plus 1. यानी h2x is equal to h2x is less than equal to hx plus 1. So अब हमें देखना है. Now we have to see hx is log 2k and this one is hx plus 1. A minimum value of hx possible will be 0. minimum value of hx will be 0 for COD event. So for COD event, hx will be 0 for COD event. Then after, so this one is written as 2hx. So when hx is 0, hx is 0, hx is 0, then which one is equal? hx and hx square. Yes sir. And this one is not equal. hx and h2 ka power x, it will be not equal. It will be not equal. And hx and h2x will also be not equal. h2x, because 2x is equal to 1, 0 plus 1, 1. So it is not equal. So h2x is not equal. hx2 ka power x is not equal, but hx and hx square will be equal. hx and hx square will be equal. Now we can say that first option is given, hx is less than equal to log 2k. So this option is correct. Next option is given, hx and hx is less than equal to h2 ka power x. Equal to will be not there, it will be less than. Equal to is wrong. Equal to is wrong. Equal to नहीं होना चाहिए था. क्या नहीं होना चाहिए था? Equal to नहीं होना चाहिए था. Equal to is wrong. So correct option will be hx will be less than h2 ka power x, because equal to will be wrong. Less than it will be less than. Correct. C option hx is, so this one is wrong. hx is less than equal to 2x, so equal to is wrong. So this one is also wrong. D option, hx and is less than equal to hx square. Yes. Equal to, correct. And less than it will be. Because this one is 2hx, this one is hx. So hx and 2hx will be less than, hx will be less than 2hx. So this one is correct. And it will be equal to when both are 0. hx is 0, so hx and hx square both are 0. So it will be correct. So D option will also be correct. In case of 0, they are equal, and in case of non-zero, they are, if this one is greater than this. So in case of not equal to 0, this one is greater than this, and in case of 0, it will be 0. But this one is equality will be not hold, so B and C option will be incorrect. A option is always correct. A option is always correct. So option is our B, A and D. Option is A and D. This one is question in which they are asking maximum value. Every time it is asking minimum value, but right now they are asking maximum value. What is the maximum value? So we are going to calculate maximum and minimum value. So first of all, we know how to calculate channel capacity. It is from basic type question, means you know the derivation of channel capacity, then you will attempt this question. If you don't know the derivation of this channel capacity, you will not attempt this question. It will be very tough. So first of all, you should know the channel capacity, how we will derive. So I taught in the class, but right now I cannot taught this, because this will take 2 hours to more than 2 hours, 3 hours. So first of all, I taught in the class that A, B, C should be equiprobable. It is given or it may be not be given. It is given or it may not be given. It is simply a memory based question. So I am taking that probability is given 1 by 3, 1 by 3, 1 by 3, because we are taking 1 by 3, 1 by 3, 1 by 3 at last. Then after we have to calculate first of all channel matrix, then joint matrix, then joint conditional probability, conditional probability entropy, and then after we will calculate average information, then we will calculate capacity, then we will calculate maximum value. So it will require more and more step. That means it will, first of all we have to calculate this channel matrix, and we have to calculate joint matrix. Then we have to calculate conditional entropy. It is lengthy type question. Then after we have to calculate mutual information. Then we have to calculate channel capacity, and then we have to calculate channel capacity maximum value. So this much step it is required. It is required this much step. So it will be little bit time taking question. So first of all, I will go through channel matrix. So for channel matrix, we will write X here and Y here. X, A, B, C. It is class based question. I have taught in the class, so it is class based question. A, B and C. So A. So the transmitting A, receiving A, it will be 1 minus alpha. A to B alpha, A to C 0, and B to A 0, B to B 1 minus alpha, and B to C alpha, and C to A alpha, and C to B 0, and C to C 1 minus alpha. It is written here. Okay, so 1 minus alpha, something right like this written here. Then after we have to calculate Py given X. Py given X mutual means we have to calculate joint entropy. So in case of joint entropy, first of all you will apply, in case of joint entropy, you will multiply the probability function A, B and C, and then after here also A, B and C. I use simply multiply this question. Simply multiply means here the probability of A will be multiplied. So probability of A is 1 by 3. In this row, probability of B will be multiplied 1 by 3, and in this row probability of C will be multiplied. So like this we are multiplying. So first of all we are multiplying probability of A, so 1 by 3, alpha by 3 and 0, 0, 1 minus alpha by 3 and alpha by 3, alpha by 3 and 0, 1 minus alpha by 3. Simply we are multiplying 1 by 3, 1 by 3, 1 by 3. Then after I will write Py given X also. So Py given X is like this. Py given X is like this. A, B, C, A, B, C, 1 minus alpha, alpha, 0, 0, 1 minus alpha, alpha, and alpha, 0 and 1 minus alpha. Like this we are writing. Then after I will calculate Hy given X. Hy given X. In this case we will write joint probability. Here we will write joint probability, and in log base we will write conditional probability. Like this we are calculating the conditional probability, conditional entropy. So first of all I will write joint probability 1 minus alpha by 3, and the conditional probability for this 1 minus alpha by 3, the conditional probability is 1 minus alpha, and it is coming 3 times. So I will multiply by 3. Here minus will come, minus, like this. Then after second way, this one is alpha by 3, and the conditional probability for this is alpha. Conditional probability will be alpha, and it is coming 3 times, so it will be multiplied by 3. Alpha by 3, alpha by 3, alpha by 3. So we are cancelling out, we will get minus 1 minus alpha log 2, 1 minus alpha and alpha log 2 alpha. Then after we will calculate mutual information. Mutual information is Hy minus Hy given X. Hy minus Hy given X. Since input and output are same, you can calculate by also hx minus x given y, hx minus hx given y. You can calculate like that also. तो आपको कैलकुलेट करना है, you can calculate by using any one formula, hx hx given y या hy given x, because input and output are same. Input and output are same, so we will calculate using any formula. So by using this formula we are calculating, because hy given x we know that. So hy and hy given x is minus time, so minus minus plus 1 minus alpha log 2 alpha and 1 minus alpha, and then after alpha log 2 1 alpha log 2 alpha, like this. So first of all we have to calculate channel capacity. Channel capacity is maximum value of IXY, maximum value of IXY. So alpha is constant, so HY should be maximum. Alpha is constant, so HY should be maximum. So 1 minus alpha log 2 1 minus alpha and alpha log 2 alpha. By using this we can calculate. So HY maximum value, so maximum value HY, the output y is 3, so log 2 n, so here log 2 3, maximum value will be log 2 3, considering equal probability. Log 2 3, 1 minus alpha log 2 1 minus alpha and plus alpha log 2 alpha. So we can calculate the graph. We will draw the graph of IC channel capacity. We will draw the graph of channel capacity. Log 2 3, 1 minus alpha log 2 alpha and 1 minus alpha and alpha log 2 alpha. We will draw this. Then we know that alpha is the probability, so minimum value of alpha is 0. Alpha is the probability, so minimum value of alpha is 0. So by putting 0, log 2 1 0 and यहाँ पे 0 रखेंगे, so it will be 0. So this one is also 0. So in case of alpha is equal to 0, this one is 0, this one is 0, you will get CS. CS will be log 2 3 when alpha is 0. Next CS is log 2 3 when alpha is 1. In case of alpha is 1, alpha 1 0, alpha 1 0 and 0, the 0 into log 2 0 होता है, so it will be 0. 0 into log 2 0, 0 into log 2 0 will be 0. 0 into log 2 0 will be 0. Understand? So 0 into log 2 0 is 0. So we are getting here also. And in case of alpha is equal to 1 by 2, in case of alpha is equal to 1 by 2, CS is equal to log 2 3 and this one is equal to minus 1. This one is equal to minus 1 by putting 1 by 2, log 2 1 by 2, minus 1 by 2, and here 1 by 2, minus 1 by 2, so it will be minus 1. You can calculate by this. You can calculate. It is a very easy process. By this you can draw this. By this you can draw this. If you draw this, the graph will be like this. The graph will be like this. So in case of alpha is equal to 1 and in case of alpha is equal to 0, you will get log 2 3, and in case of alpha is equal to 1 by 2, you will get log 2 3 minus 1. So you will say how you are getting alpha is equal to 1 by 2 minimum value. By differentiating you will get minima. So for minima you have to calculate. For minima dCs upon d alpha will be equal to 0 and you will get alpha is equal to 1 by 2. Then d square cs upon d alpha square will be equal to 0, will be equal to less than greater than 0, will be equal to greater than 0 at alpha is equal to 1 by 2. So minima, so it is minima. You can calculate, you can do this by yourself. but you have studied for about binary symmetric channel 1 plus something p 1 minus p and log 2p like this you have studied. So in case of binary symmetric channel like that you are getting this one, but this one is only changing. Here you are getting 1 in binary symmetric channel and here you are getting log 2 3, but only this thing is we are changing, and this one is same as it is binary symmetric channel. So we are getting the graph like that. So we are getting they are asking the maximum value. They are asking the maximum value. So maximum value will be at alpha is equal to 0 and at alpha is equal to 1. So where we will take, you will take this value, alpha is equal to 0 or alpha is equal to 1. So maxima you have to consider, and the value of alpha is 0.25 to 1. So we are getting alpha is equal to 0 and then here we are getting alpha is equal to 1. But in domain alpha is equal to 1 is here present, but alpha is equal to 0 is not present in this domain. So we will take alpha is equal to 1. So answer will be alpha is equal to 1. Answer will be alpha is equal to 1. Alpha is equal to 0, why we are not taking? Because it is not written in the domain. So it is not written in the domain, so I will take alpha is equal to 1. Simple question, simply question, but lengthy question. It is taking time. So it is lengthy question. Thereafter, I will go through. This one is the last question. There are 8 questions they have asked, but right now I have got only 5 question memory based question, because 2-3 questions some data is missing or something is missing. So I am not getting that a perfect question. If perfect question will come, I will discuss, but here no perfect question is come. This one is memory based question, so I am trying to solve memory based question. 3 question is remaining. I didn't get that. If you have, you can share with in Get Academy channel, and I will surely discuss, or if paper will come out, then I will discuss it. So I am discussing this one. This one is the repeated type question. This one is asked many times. Many times means 7 to 8 times, approximately 8 times they have asked. So this is repeated type question, and it is asked in 7 to 5 times, means 6-7 times they have asked. First of all, how much data we are transmitting? So from this code we know that we are transmitting 7 bit per symbol. Means for one symbol we are using 7 bit. What is 4? 4 is message bit and 3 is parity bit. So we can say that like this. This one is n, this one is n, and this one is message bit, and this one is parity bit. This one is parity bit, and this one is message bit. So message bit we are taking 4 and parity bit we are taking 3. So 4 message bit we are transmitting, 4 message bit. In place of 4 we are transmitting 7. In place of 4 we are transmitting 7. So transmitting 7 bit at a time. So we will not take 4, we will take 7. So this question is tricky question. First of all, he want to know that what we will take, 4 or 7. So I will take 7, not 4, because 4 we are not transmitting, we are transmitting 7 bit at a time. So error will be possible in all 7 bits. Here error will occur, or here error will occur, here. In 7 bits, anywhere error will occur. The student will be confused, we will take 4 or we will take 7, because this one is message, so we will calculate error in message, or we will calculate error in code word. So we will calculate error in code word, because we are transmitting code word at a time. So code word we are transmitting, so I will take code word as a message bit. Code word as a message bit. Then we are transmitting this message bit. So we know that this 7 bit we are transmitting at a time. So it is possibility that 0 is error, or it is possibility that 1 is error. So there are many possibility. They are asking at most 1 error. They are asking at most 1 error. So we have the possibility that 0 error, or we have the possibility that 1 error. So out of 7 bit, no error. So error is 0.1, no error is 0.9, 1 minus 0.1, 0.9. So there is no error. So all are in no error, all 7 bits are in no error. This one is binomial distribution, you know that. 7C1, 1 bit error, so 0.1 power 1 and 0.9 power 6, like this. So you will calculate in a perfect way. If you will calculate, if you will do approximation here, then adding and then you will get approximation here, your answer will be vary according to answer key. So you have to take a precise way, that you have to calculate in a precise manner, 4 bit, 5 bit type answer. This one is 4 bit, 5 bit type answer. Then after you will add and then you will round off. So you will get the correct answer as the given in the IIT. So you have to understand this. The answer, putting answer, because many people will calculate this answer, but they will don't know, they will do error in filling the NAT question. Numerical type question, you will fill the numerical type question, you will get error. Because you will round off here, then after you by adding, you will round off. So the answer will vary. So this will be, you should take care of this thing. Okay? So I am calculating this answer. So this one is 0.7, 0.9 power 7 plus 0.1 into 7 and 0.9 power 6, like this. So 0.9 power 7, it is 478. Get calculator I am using 2969. And next one is 0.9 power 6 into 0.7, it is 0.3720087. Now you can add 0.4782969. Then you are getting 0.8503056. If they are asking 2 decimal places, 0.85. If they are asking 3 decimal places, 0.85. 850. 0.85 or 850. So answer will be 0.850. Now you can get the calculation. Now you can do the calculation. After that you will get the answer. So हमारा यहीं पर discussion, our discussion will end here. If you will get more question, we will discuss later, or we will discuss in the question paper analysis. So question paper analysis in paper, we will do everything in a planned manner. Thank you very much.
Yeah, good evening everyone. So now I am going to take question from the signal and system. Okay. Earlier we have discussed question from network and digital electronics. Okay, in network, if you remember one question, voltage was given and current was given. In that already I discussed either you will take plus pi by 4 or minus pi by 4. But now I have checked again. So now according to me in that question, the answer will not be capacitor is equal to 1 farad. So the answer will be inductor is equal to 1 Henry. Okay, so just here to correct that answer. Okay, so now here I am going to take signal and system, and here 3 question has been asked. First question is from the Fourier transform, second question is from the Laplace transform, and third question is from the DFT. So first question I am going to take. This first question was given here. This was the first question, question number 1. This was your first question. So here Fourier transform of xt you have to find out. So Fourier transform of t upon 1 plus t square whole square. This Fourier transform you have to find out. So this Fourier transform we have to find out, and this is a multiple choice question, MCQ, 4 options they have provided. But I don't have, okay, so I am not going to write here 4 options, just we will find out the exact answer. Okay, so now here we know very well e raised to power minus at, this is standard, and this Fourier transform, and this Fourier transform is 2a upon a square plus omega square. We know this thing. Okay, now so suppose for example if I will put here a is equal to 1, if we will put here a is equal to 1, why I am going to put, because here we don't require here, I required here 1, I required here 1, because later we will use duality property. So what we can think here, this is a very basic equation, so you can relate this t with omega square. So how you will get omega square in Fourier transform? By e raised to power at, by e raised to power minus at, you can say, into ut. But okay, e raised to power minus of a mod t, then you will get here omega square. So but here t square they have mentioned, so can you use duality property? Yes. So from that we can think e raised to power minus at Fourier transform. So if I will put here a is equal to 1, why I am going to put here a is equal to 1? Because you can see here this is t square plus 1. So right now I need omega square plus 1. So what we will get from here? We will get from here, sir, e raised to power minus of this is mod t, and this Fourier transform, now this Fourier transform will be, this is 2 upon this a is 1, so 1 plus omega square, 1 plus omega square. So now you can see t is also multiplied. You can see here t is multiplied, so can I multiply here t? So multiplication of t property can we apply here? So if we will multiply by t here, multiply by t, e raised to power minus of mod t. So what will be this Fourier transform? So this Fourier transform will be nothing but z d by d omega, z d by d omega, and this x omega. So this x omega, so this is 2 by 1 plus omega square. Can I write in this way? Can I write in this way? So what we will get from here, sir, t e raised to power minus of mod of t, this Fourier transform, this Fourier transform will be here, this Fourier transform will be here, just you have to differentiate here. So what we will get exactly, so this is z, what is differentiation of this? So z in denominator we will get 1 plus omega square whole square, 1 plus omega square whole square, and 1 plus omega square into 1 plus omega square into differentiation of 2 is 0, differentiation of 2 is 0, minus of 2 into differentiation of denominator, differentiation of denominator is 2 omega, this is 2 omega, so this term is 0. So what is a Fourier transform of e raised to power of minus of mod t, and this is nothing but here this is z. So what I will get from here, this minus of z for omega divided by 1 plus omega square whole square, divided by 1 plus omega square whole square. So now you can get this is t upon 1 plus t square whole square, and now you are getting from here omega upon 1 plus omega square whole square. So this minus of j4, you can say this is a nothing but one constant term. So now can we use here duality property? Can we use here duality property? Can we use here duality property? Yes, definitely we can use here duality property. So just you can shift this to left side and you can shift this to right side. So if I will write this term at left side, so what we will get? Sir, this is minus of j, this is 4, omega will be replaced by t, divided by omega will be replaced by t. So this is 1 plus this is t square whole square. And now what will be this Fourier transform? This Fourier transform, this will be replaced by here 2 pi you have to multiply. You have to multiply by 2 pi and this t will be replaced by minus omega. T will be replaced by minus of omega, and you can also write this e raised to power minus of, this is mod of minus omega. Mod of minus omega will be mod of omega. So this term you can write, this term we can write minus of 2 pi omega e raised to power minus of mod omega. So for this Fourier transform, you have calculated here. So now but examiner have asked t upon 1 plus t square whole square, t upon 1 plus t square whole square. So this minus of j omega you can shift here. So what we will get from here? So t upon 1 plus t square whole square, and what is this Fourier transform? So we will get from here minus of 2 pi divided by, this is minus of j4 into, this is omega e raised to power minus of omega e raised to power minus of omega. So now this minus and minus will be cancelled out, this minus and minus will be cancelled out, and here what we will get? Here we will get this is nothing but pi by z2 into omega e raised to power minus of mod omega, and here option was given pi by 2j omega e raised to power minus omega. So this was the correct option. So this is a MSQ question, sorry, this is a MCQ question, and 4 options they have provided. In one option this is pi by j4, in second option this is 2 pi by j, like this kind of 4 options they have provided. So here this is t upon 1 plus t square whole square, Fourier transform is this one. So here duality property we have to apply, here multiplication property we have to apply, and one standard exponential function Fourier transform is required. So you can say this is a basic standard question. In previous question already this kind of question has been discussed. Okay, so I hope everybody definitely you have attempted this question in your GATE exam. So 2 more questions left in signal and system. So now I am going to take another question, and another question asked from the final value theorem, or you can say from the Laplace transform. So now the second question from the signal and system, this was the second question. You can see here, one signal is given x1t and another signal is given x2t. So here 2 signal is given and one more signal is given y of t, and that y of t is nothing but a convolution of xt and x2t. This y of t is a convolution of x1t and x2t. And now examiner asking limit t tends to infinite y of t is. So if we know the final value theorem, so we can say this is we can also apply here final value theorem. So can I write from here limit t tends to infinite y of t, we can write this value in this way. This is limit s tends to 0 s of, this is ys. So either you can calculate from yt or we can also calculate from ys. So which will be easier for us? So this thing we have to think in the question. So easily Laplace transform we can calculate, and easily we can put here s tends to 0. So can I find out from here x1 of s? So here x1 of s is nothing but 1 upon s plus 1. Now second, what is x2 of s? Sir, x2 of s is nothing but ut Laplace is 1 by s minus, what is a Laplace transform of ut minus 1? This is nothing but 1 by s e raised to power minus of s. Now y of t is x1t convolution x2t. So can we write y of s is equal to x1s dot x2s. So convolution property we can apply here. So this is x1s dot x2s. So now this x1s and x2s value we can put here. So we will get from here 1 by s plus 1, 1 by s plus 1, and this we can write, this is 1 by s and 1 minus e raised to power of minus of s, e raised to power minus of s. So now if we will put a value here s into ys, so what we will get? So we will get from here limit of s tends to 0, and this s and this s will be cancel out, both s will be cancel out, and we will get from here 1 upon s plus 1 into 1 minus of e raised to power minus of s. So now if we will put here s is equal to 0, so what exactly we will get? So this is 1 upon 0 plus 1, this is 1, so we will get this value 1, and from here we will get this is 1 minus e raised to power 0 is 0, sorry, e raised to power 0 is 1. So we will get from 1 minus 1, and our result is a 0. Our result is a 0. So here final value theorem you can apply, and what is the final value? Final value is 0. So this is a numerical answer type question. I think this is a numerical answer type question. So just you have to put in the bracket 0. If this is a multiple choice question, so just you can select the answer 0. This is a very basic question. This is very basic question. Okay, so now the last question I am going to take from the signal and system. Okay, so now last question I am going to take from the signal and system, and this question, this is here question is given, and this question is given from the DFT. This question is given from the DFT. So now just I am going to read out the question first. So here one vector is given, here one vector is given, this is x bar. So the value is x0, x1, x2, x3, x4, x5, x6 and x7. So here one vector is given. So here 8 point you can say given, x0, x1, x2, x3, x4, x5, x6 and x7, and this is 8 point DFT, and 8 point DFT is denoted by, means this DFT is given. So this is given capital X bar, this is nothing but DFT of this vector, this is capital X0, capital X1, capital X2 till capital X7. Okay, so now this basic DFT formula they have also mentioned here, x of k, this value is nothing but x of k. X of k is given, this is summation of n is equal to 0 to 7, this is 8 point DFT. X of n e raised to power minus the 2 pi by n is here 8, n into k. This is basic definition of DFT. And now this x bar value they have provided, means this value they have provided, this value is 1 0 0 0 2 0 0 0. So here 1 0 0 0 2 0 0 0, it means this x bar is given, we have to find out this DFT of this value, then another value is given y, and this is again DFT of again DFT. It means what is the question? This vector x bar is given, and you have to calculate 2 times DFT. You have to calculate 2 times DFT of this. You have to calculate 2 times DFT of this. So this is the exact value. So can I say here, you have to calculate here 2 times DFT. You have to calculate here 2 times DFT. So first you have to calculate DFT of this value, then again DFT of this value, and then you will get this y, and y will be again complete vector, y0, y1, y2, y3, y4, y5, y6, y7, but examiner are only asking here y0. So examiner are interested in only y0. Examiner are only interested in y0. So here y0 we have to calculate. Here y0 we have to calculate. So here what we can do? So what is your actual question? So this is actual question. You have to find 2 times of DFT of this, and from that y0 value you have to find out. So now what we can do here? Suppose if I am going to assume one vector 1 and 2. Suppose I am going to assume one vector 1 and 2, and this DFT we have to find out. Suppose this was not exactly question. Question was 1 0 0 and 2 0 0. But by some trick I am going to solve this question. So first I am going to take here DFT of 1 and 2. DFT of 1 and 2. So DFT of 1 and 2 easily we can calculate. We know how we can calculate. So here this is a W matrix. Okay, W matrix. And here which DFT you are going to find out? 1 2. Which DFT you have to find out? 1 2. See here vector size is nothing but 2 cross 2. This is nothing but 2 cross 2, and we know very well this value is 1. Always this first row and first column, always this is 1 1 1. What will be this value? So Wn formula, everybody know. What is your Wn? What is your Wn? So Wn, we know this thing, e raised to power minus j2 pi by n, e raised to power minus j2 pi by n. So what is W2 here? What is W2? So what is W2 here? W2 is nothing but e raised to power minus j2 pi by 2. 2 will be cancelled out, e raised to power minus j into pi. And this is nothing but cos pi minus j sin pi. So cos pi is minus 1. So we are getting this value is minus 1. So this value we will get minus 1. Okay, so this W matrix we have to find out. This is your given vector, and this is the DFT of 1 and 2. So what we will get? Sir, 1 into 1 and 1 into 2. So 1 into 1 plus 1 into 2. So 2 plus 1, we are getting here 3. And sir, 1 into 1, 1, and this is minus 2. 1 minus 2. So we are getting here 3 and minus 1. So can I write here, sir, DFT of, can I write 1 and 2 is equal to, so I can say 1 to DFT we are getting here, we are getting 3 and minus 1, 3 and minus 1. And if I am saying, sir, this is xn, suppose if I am saying this is xn, suppose, so what will be xn by 2? So property of DFT we can apply. So xn by 2, what we can write? Sir, here this is 1 0, and can I write this is 2 0? Can I write this is 2 0? Because what you are doing, you are expanding the function. You are expanding the function. So here 1 0 will be added, here 1 extra 0 will be added. This is basic signal and system property. This is basic signal and system property. So here we are getting 1 0 2 0, and DFT property we can apply. So what we will get? You know very well this is a periodic function, so this will be repeated again. So this will be 3 and minus 1, again this will be 3 and minus 1, 3 and minus 1. Similarly, but what was the exact question? 1 0 0 2 0 0. So suppose if you want to write here, sir, xn by 4. So xn by 4, what you will write xn by 4? So here this is 3 times 0, you can penetrate here. Sir, 1 0 0 0, and here this is 2 0 0 and 0. So what will be DFT for this? So DFT for this will be, again you can repeat this. How much time? Total 8 values. So here 8 point you will get. So sir, 3 minus 1, then again 3 minus 1, again 3 and minus 1, again 3 and minus 1. You know this thing? This is a very basic property of DFT. So this DFT we have calculated by the tricks. So now, but what is the question? Why is DFT of this? So again one more times DFT. So DFT of this we have to find out. So DFT of this again we have to find out. So now, sir, what is the DFT of this? So now DFT of sir, this is 3 minus 1, 3 minus 1, 3 and minus 1, and one more times 3 and minus 1. How we can find out DFT of this? Again you can write, but this size is 8. So here this W matrix size is nothing but 8 cross 8, 8 cross 8, and here we can write this value. So this is 3 minus 1, 3 minus 1, 3 minus 1, and 3 and minus 1, 3 and minus 1. And this we have to calculate, but here if I am saying this result is nothing but y, if this result is nothing but y, so here you will get, sir, y0, here you will get, sir, y1, like this. So here you will get y7, but here examiner have asked only y0 value, and we know very well this is first horizontal, you can say column and row, all the value is 1 1, this is 1 1 1 1 1 1, 8 times 1, and this is 1 2 3 4 5 6 7 8, this 8 times 1, this size is 8 cross 8. So we don't have to put here all the values, because examiner are interested in here only y0, and to calculate y0 only this value is required for y0. So what I can say, for y0, calculation of y0, only this value is required. So we don't have to complete this matrix. So easily y0 we can find out. So can I write y0 is nothing but 1 into this, 1 into this, 1 into this, 1 into this. So just you have to add all this value. So this 3 minus 1, we can say, sir, this is 2, 3 minus 1, this is 2, 3 minus 1, this is 2, and 3 minus 1, this is 2, 2 2 2 2. So y0 answer will be 8. So y0 will be 8. Here y0 will be 8. Here y0 will be 8. Here y0 will be 8. So this was a good question, okay, but only we have to apply here. Only we have to apply here DFT property. Only we have to apply here basic DFT property. Okay, so just in this session I have discussed 3 number of question from signal and system. Okay, so if anybody have any queries from here, just you can ask me. Okay, and I am going to complete my session. I have conducted 3 subjects here. All the questions from network, all the questions from digital, and all the questions from the signal and system. Okay. Okay, so now okay, so just you can wait 5 minutes. Okay, and Das sir will start session for the electronic devices and circuitry. Okay, thank you and wish you all the best to all of you.
नाइट मोड करूँगा तो
इमेज है ना,
इमेज है, पीडीएफ होता तो हो जाता ना। तो कैसे बनाएंगे, दिख रहा होगा बच्चों को?
हाँ सर दिखेगा ना।
अच्छा, okay, hello everyone, welcome to Gate Academy, and I hope you have all done well in your electronics branch examination that has already over in the morning session. I hope my audio and video is clear, and this text what I have written here in image form that is also clear. Is it clear? Tell me once. Hello everyone. I just reduced the brightness of this camera, that's why I am asking to get the proper image. कोई है ही नहीं। कहाँ गया बोर्ड? ये है क्या क्वेश्चन? बैनर कहाँ गया?
वो बैनर ना अपने आप हट रहा है बीच बीच में,
तो और ऐड करो।
तो मेरा प्रीवियस क्वेश्चन इससे जाओ ना।
नहीं सर, 1 स्टार्ट
सर 1 से स्टार्ट।
अच्छा 1 से स्टार्ट है,
हाँ
ठीक है। ये लाइन चला गया इसलिए कंफ्यूज हो गया। चलो ठीक है। Okay students, we are solving the question. Right now I have the question from the semiconductor part. In a non-degenerate bulk semiconductor, not degenerate means the semiconductor which does not doped at much quantity such that the semiconductor will behave as a metal. So that means in non-metal, or we can say this particular device in which we have doped with donor atoms, it is basically acting as a semiconductor only. So no need to confuse, this is a semiconductor if the word is not degenerate is mentioned. If the word you will find in any question degenerate, then the meaning of degenerate semiconductor is the semiconductor is doped as much as it is working as a metal. In that case, the formula that we are in general using for semiconductor you cannot apply. That's why the IIT has given the question in such a way that you just does not confuse with non-degenerate word. If you get confused also, the meaning will be the same. Okay, that means it is a semiconductor only. In a non-degenerate bulk semiconductor with electron density n is equal to 10 to the power 16. पुष्पेंद्र इसमें visible नहीं है, दिख जा रहा होगा?
जी सर सही तो
है ना? ठीक है. Electron density n is equal to 10 to the power 16 per centimeter cube. The value of, so we have the concentration of donor atoms in n-type semiconductor, that is n is equal to 10 to the power 16 per centimeter cube. This will be the question. The value of EC minus EFN. So here one value is given, that is EC minus EFN, where EFN is the Fermi level position and EC is the lowest energy level of conduction band. So I just write here 1 is equal to, that is equal to 200 milli electron volt. This is the difference in energy that is given. And next is assume the thermal voltage as 26 millivolts. So VT value is given, that is equal to 26 milli electron volt. That is already we know from our basic semiconductor knowledge. And intrinsic concentration, that is Ni is equal to, that is of course it is 10 to the power 10. 10 to the power 10 per centimeter cube is given. Okay. Next is for n is equal to 0.5 into 10 to the power 16. Now we have, this is one concentration already given in the question. Now we have the second concentration. So I am writing with different pen, that is this given by N2 is equal to, it is given that 0.5 into 10 to the power. So it is 0.5 into 10 to the power 16 per centimeter cube, that is already given. And the closest approximate of the value of EC minus EFN among the given option is, the closest approximate value we have to find out. Which value? That is EC minus EFN, again we have to calculate, but this time this is denoted by 2 and this is actually the question mark. Now we have to connect these two given data. That means we have to connect the concentration with the difference in the position of EC and EFN. How to connect? We already know the formula. What will be the formula? The formula is, already I told you many times, that is N is equal to NCE to the power of minus of EC minus EFN upon KT. That will be the formula. So many of the students may think that NC is not given. Since NC is the effective density of state at the edge of the conduction band, this must be taken as constant because we are in general increasing the doping concentration and the effective density does not increase with doping concentration. That's why this particular part can be taken as constant. So this particular part can be taken as constant. So in that case we can solve this question, very easy one, because we have to take the ratio, and by taking the ratio we can easily solve. So I just take a slide now, and in this slide I can solve this one. So this is N1 divided by N2, because we know both of this one is equal to we just take this is NC and again divided by NC, and here we can write this is EC minus EF and N, and what is the quantity? This is the first one, that's why I am writing here this is 1 divided by KT, and next the ratio is given by e to the power. This is again EC minus EFN again, but now the second thing we have to write down, and this particular part is taken as the question mark. So I have the all the values here. In the previous slide we have written the values. So the values will be, this is 10 to the power 16, this is 0.5 into 10 to the power 16. So I will take the values. This is 10 to the power 16 and this is 0.5 into 10 to the power 16. That's what already given. So NC will get cancelled and we have to take this part. So I am removing this question mark part here, and I will write here this is e to the power EC minus EFN 1. That means the difference, already we have taken the difference. Here is the difference, that is 200 milli electron volt is the difference. So I just write here this is 200 milli electron volt. I am writing with this particular part also. So if you can ignore, you can ignore that part. That is 200 into 10 to the power of minus 3, and this KT is 0.026. So I can write here, here this is 26 into 10 to the power of minus 3 also. Okay. So this is the part, and this must be divided by, this is e to the power. Again we have to write this is EC minus EFN again, and now this is 2 divided by KT, again 26 into 10 to the power of minus 3 we can write. So this is 26 into 10 to the power of minus 3. So of course we have to cancel out this to 10 to the power 16 and this will become 2, and here we can write this is e to the power. I just take okay, this is minus sign would be there because minus of EC minus EFN upon KT. I think that you have take care of all these things. Okay, so minus sign will be there, and I have taken this minus sign here, and if it has been taken above, then this will be equal to EC minus EFN, and here we can write this is 2 minus. So this minus sign is normally here, and this is 200 into 10 to the power of minus 3 divided by, the whole thing will be divided by 26 into 10 to the power of minus 3. Okay. So I think that now it is easier for you also. So I just draw a line here. Okay, I have drawn a line here. Now this particular part has to be solved by using calculator. So I just take ln of 2 here, and this will be equal to, this is EC minus EFN and 2 minus 200 into 10 to the power of minus 3, that is there, and divided by, this is equal to 26 into 10 to the power of minus 3. So we have to find out what is actually EC minus EFN2, and that is the part we have to find out. And we just write this is 26 into 10 to the power of minus 3, and we have to take ln of 2, and we just have to write this is plus of 200 into 10 to the power of minus 3. Of course the answer will be in milli electron volt, because here we are having the difference in energy. So of course the answer will be in milli electron volt. That's what I want to say. So what will be the answer? That is 26 into 10 to the power of minus 3. If we take 10 to the power minus 3 common, then the answer would be in milli electron volt. So I just remove this part here, and this part from here, and this is also has been removed. So I just write here this is in okay, so I just put this part here. Okay, just I am removing the 10 to the power minus 3 part, and this is the correct value, and just put this answer. Okay, so answer will be, just I have calculated that part also. The answer would be 26 ln of 2 plus 200. So this is 200 plus some part, that is equal to, I think this will be equal to 218 milli electron volt. Okay, so I just check out the answer here. You can also calculate and check. that is 218 milli electron volt. I hope all of you got this answer while writing the examination in the examination hall. And this is the formula that we have to use. This is just a formula. If you read the question and just landed up to this formula, then you can easily do this question, and the answer would be D in my particular question. It may be at different position. This 218 will be at different position in your examination. This is my in my question, this is answer is D. So don't confuse with D. The answer is 218 milli electron volt. So this is the first one that I have taken for you. Okay. So next one is like this. Okay, I will take another one. Okay, this is an MSQ question. I think that this must be visible to all of you. So this is an MSQ question. Select the correct statement regarding semiconductor device. So we have to take the correct one from this particular part. Mobility of electrons always increases with temperature in silicon beyond 300 Kelvin. So if we increase the temperature of semiconductor device, the mobility always decreases and the concentration increases. So in that context, if you say that mobility of electrons always increases with temperature in silicon beyond 300 Kelvin, that is wrong. So I think that this particular part is wrong, and this is not the correct answer for this question. And second is electrons and holes are of equal density in an intrinsic semiconductor at equilibrium. That would be correct, because if you are talking about intrinsic semiconductor, already here they have written intrinsic semiconductor, so Ni would be taken as electrons concentration is equal to, we can write the holes concentration. So equilibrium means we are not applying any energy. So that means the value of any energy, any form of energy like electric field, voltage, or we can say temperature, or we can say energy in the form of photon, we are not applying. So that's why I have written this is energy, this is representing energy, energy is equal to 0. That means the semiconductor is in equilibrium condition, and that is correct. So I just put a right sign here. Total current is especially constant in a two-terminal device in dark under steady state condition. So if you draw the characteristic under dark condition in a two-terminal device, that characteristic can be drawn like this. So dark means we are not applying any source of light. So this is the characteristic, and in this is voltage and this is current. They are asking about this characteristic, and this characteristic is constant with respect to we can say with respect to voltage, with respect to position, everything. So that's mean we can say that this particular point is also correct, and I just put a correct sign here. This is correct for a two-terminal device, because every two-terminal device, that will be a diode, that will be a photodiode, that will be a solar cell, that is LED, any diode, any two-terminal device if you take, this is the characteristic, and this particular characteristic in which we have drawn this line, this particular line representing the dark current. This is line representing the dark current, and this is need not change with the voltage. Okay. So I think that this is also correct, and collector region is generally more heavily doped than the base region. This is the normal doping criteria of a BJT, that is the collector concentration is always greater than the base concentration, and we know that the emitter concentration is very much greater than the collector concentration, and the lowest concentration would be taken as the base concentration, and this is the case of BJT. So among we can say these four options, 3 options are correct. Just I have put a tick mark here so that you can get the correct one. So this is the way by which we can take the MSQ, because only we have to read the options and we have to take the concepts that is present already in your mind, and we have to answer that part. That is the thing that we have to do. And next we are going to take the correct answer for this MSQ is, we can say B, C, D. If you have taken this one, then that will be correct. If you have taken the wrong answer, then there is no negative marking. Just we have to ignore this question and move to the next part of your EDC. And this is one question that is taken from, we can say MOSFET, and especially MOS capacitor. and this is my favorite part, that's why I am taking this one. An ideal MOS capacitor p-type semiconductor. So the design is already given and we have to take this is a p-type semiconductor. So already semiconductor is mentioned here, we have the p-type. So in this p-type, the inversion, so we have to apply a voltage here, this is the gate voltage. Because of this one, if the gate voltage is greater than the threshold voltage, then we know that we have the concentration of we can say inversion charge, depends upon in which direction we are applying the voltage, either positive or negative. Since this is a p-type semiconductor, so we have to apply a positive gate voltage to get a threshold voltage, that is already known to you. And because of this positive apply voltage, we have the electrons concentration that is accumulating here. So we have the electrons concentration, that is electrons concentration at the surface of this semiconductor. So an ideal MOS capacitor p-type semiconductor is shown in the figure. The MOS capacitor is under strong inversion. So the word strong inversion has been used here. So I just write here strong inversion means the inversion that comes into existence when we increase the voltage of gate beyond threshold voltage. So a strong inversion means Vg is greater than threshold voltage. Okay. The corresponding inversion charge density. So here we are having some charge and they have given the charge density per centimeter square. That means how many charges has been accumulated here on the surface of the interface where we are having silicon dioxide and semiconductor. So here we are having this small white color space is representing metal, of course, this is oxide and this is semiconductor. Here we are having electrons concentration and this is called Q inversion because because of application of voltage in a p-type semiconductor, we are having the electrons concentration here, that's why this is like this. Okay. So we have taken assume oxide capacitance per unit area. So I think that I have taken enough things here. Now we are taking the data. COX is equal to 1.7 microfarad per centimeter square. Here it is given, and we are having gate voltage is equal to 4 volt. Okay, and this is the second gate voltage. I must say that there is another one voltage that is applied previously, that is Vg1. Okay, Vg1 is equal to, that is 2 volt already applied. Okay, so in that 2 volt we are having Q inversion. So corresponding to that Q volt we have Q inversion that is equal to, we can say 2.2 microcoulomb per centimeter square. This is given. Okay, so corresponding to this voltage here we are having Q inversion, and corresponding to this voltage we have to find what will be the Q inversion. That is the actual question. So some data has been given and we have to connect with the formula. What will be the formula? Again I am writing the formula above, that this gate voltage, if we apply gate voltage and if the gate voltage is above threshold voltage, definitely we are having the inversion charge. So we are having the Q inversion charge, and this is given by COX into Vg minus V threshold. This is the formula by which we can find out. So here we are having two values. So if you find the data given here, first thing that we have to find out here, there is no threshold voltage. So threshold voltage we have to find. Then in the second case, when we apply Vg2 is equal to 4 volt, in that case we have to find out what will be the Q inversion. Actually this is the question. So first thing we have to find out the threshold voltage. Already in previous gate exams they have asked one time about this particular questions. In that the data is so many, that means first time gate voltage, second time gate voltage, third time gate voltage, like this. So this is the formula that we have to apply. So we just need to the first one. So we have to calculate the threshold voltage from the given data that is given for first one. That is Vg1 is equal to 2 volt and Q inversion is equal to 2.2. In that case we have to find out what will be the threshold voltage. So the formula is Vg minus V threshold we have to find out. Here is the threshold voltage, and we just write here this is Q inversion divided by COX, and we just have to calculate this value. So this will be Vg plus this is Q inversion divided by COX value, and we just take this one, the other side, this is V threshold. Okay, we have to subtract this one. Okay, so these are some silly mistakes that we can do when we are not in presence of mind. So this is threshold voltage, we have taken this side, and this is Q inversion minus COX. So from there we can find out the value of this threshold voltage. So what will be the values given? So Vg1 is equal to 2 volt, Q inversion is equal to 2.2 in 2.2 microcoulomb. So here we are writing this is equal to 2 volt, and okay, this is equal to 2 minus Q inversion is equal to 2.2, and this is 1.7. The unit will be the same, and this is threshold voltage. I think that threshold voltage is approximately equal to 0.7 volt. That is already calculated. So after this, what we have to do? We have to just find out the second one, and this all things is the first one, the gate voltage, and this Q inversion is first one. So I have taken the subscript also. This is first one. So in the same threshold voltage, that is Vt is equal to 0.7 volt, we have to take what will be the Vg2 minus Vt, and now we have to find out what will be the Q inversion charge, and this is the second one, and COX will be the same. Okay, so I have to find out what is the Q inversion second. This is equal to COX into Vg2 minus threshold voltage. Okay, so COX is equal to 1.7, Vg2 is equal to 4 minus 0.7. Okay, so I think that from here we can find out what will be the Q inversion. Is that correct? So I just use the calculator here. .3 into 1.7. That is 5.6. So answer is approximately 5.6 microcoulomb per centimeter square. So I think that many of you have done this one, because this is very easy one. Okay, so next is, I will take the next one. This is another question that is from the CMOS part. Consider the CMOS circuit shown in the figure. Substrate are connected to the respective sources. The gate width W to the gate length L, W upon L of the transistor are shown. Both the transistor have the same gate oxide capacitance per unit area. So there is a circuit in which we are having, one of them is a PMOS and second one is NMOS. So whenever we have the circuit, we have to first identify the terminals. So here we are having the terminals, here we are having the terminals, and here and here. And what is this? This is the drain terminal. Okay, sorry. Since this is a PMOS, then we can say this is the source terminal of PMOS. And this particular terminal is drain terminal of PMOS, this one. Okay. And this is the gate terminal of PMOS. Again we are having here, I just changed the color of the pen. This is the NMOS gate terminal. This is the source terminal of NMOS, and this terminal is nothing but the drain terminal of NMOS. Okay, so in this way we can write. Now we have to do one by one. So this is NMOS, this is PMOS, and we have to find out what will be the output here. This is the question mark. So for this type of questions, the most helping formula is the drain current formula. Since we know that the current throughout this device is same, that is ID, and we can write this is IDN is equal to IDP, because this is connected in series. So this is the first thing that we have to consider. Second thing is that we have to say that this is under saturation. Why it is under saturation? Whenever the gate terminal is connected to the drain terminal, the semiconductor is working in saturation, because in that condition we just can write that VDS should be greater than equal to, this is VGS minus VT. This condition is always true. So whenever these two terminal are get short circuited, so always true. So that's why I can say that these two device is working in saturation. So if it is in saturation, we have to take the formula for saturation condition and do accordingly. So what is the formula for saturation? Suppose I am writing for NMOS, the saturation condition is IDN. This is 1 upon 2, and then we can write this is mu n COX and W upon L ratio of the NMOS first, and then we can write this is VGS minus P threshold of NMOS, and this is the square of this. And for PMOS, because the another transistor is PMOS, so IDP is equal to, this is half, I can write this is mu P COX, and W upon L ratio is different for both this one, so I can write this in this way. Then we can write this is VSG, because this is PMOS, so I just toggle this source and gate, and minus this is mod of threshold voltage of PMOS and the square of these things. Okay, and since we know that the current will be the same, so already I told you that this ID is equal to, we can write this is IDN is equal to IDP, all are same. In that condition we can just take the equal of this one, so I just write this is half, then we can write this is mu n COX W upon L, and this is for n, and we just take this is VGS minus VTN square. Okay, and here we can write this is half, then we can write this is mu P COX W upon L, and this is for PMOS, and this is VSG minus mod of VTP and the square of this. From here we can identify where is V0 located. Since we know that gate and drain are short circuited, and this gate terminal voltage, this VG is actually short circuited with drain terminal, and this drain terminal voltage is nothing but the output, and we have to find out the output. So if you expand this particular equation, then we can easily get the answer. So I just say that this half and half will get cancelled, and this is mu n COX value is already given in the question, and W upon L ratio is also given in the question, and I just expand this one. This is output voltage minus source voltage minus threshold voltage of n square. Then we can write this is mu P COX, and this is W upon L again, and for PMOS, and again we can write this is source minus gate minus mod of threshold voltage of PMOS ka square. Okay, since we know that the gate terminal voltage is again the output voltage, so we can just remove this part here from here, and we just put V0 here. So we just put V0 here, and that is, so we are having V0 here, we are having V0 here, and there is only one thing that is unknown here, so we can find out the unknown value from this particular question. So we just take this is mu n COX W upon L. Okay, we can put the values now. Okay, so I just take the reverse one, and I know what will be the value. So W upon L for PMOS is given 5, W upon L for NMOS is given 1. So I just put here, this is PMOS is 5, and here we are having 1, and mu n COX value, what is given there? So the threshold voltage is minus 1 volt, the mobility of holes is 40 centimeter square per volt second. Okay, both the transistor have the same gate oxide capacitance, that means COX will be the same per unit area, that means COX for PMOS is equal to COX for NMOS. So we just cancel out these two. Okay, I just take the cancellation of these two. Okay, so this COX will get cancelled with this COX, and what next? I just write here, and 40 and 300. So mobility of electron is 300 and mobility of hole is 40. So again I will go there, and mobility of electron is 300 and mobility of hole is 40. So we just put the values, and the rest of the thing is taken care by itself. This is V0 minus source voltage will become V0, and threshold voltage is 1 volt, and the square of this one is equal to, this is source voltage, actually drain source voltage of PMOS is connected to 4 volt. So I just write here 4 because already it is given. Okay, this is 4 volt, okay, and this is the source terminal of PMOS. So I just take this one, this is source terminal of PMOS, so I just put 4 value, minus V0 minus threshold voltage is 1 volt, and the square of this one. So this is the whole thing. Here we have to find out the value of V0. So I think that from here we can do by calculator. So what is the value of V0? So approximately we are getting V0 value is equal to 1.8 volt. Okay, so this is the correct answer. So approximately we are getting 1.8 volt. So if we are getting 1.8 volt, then definitely we can write here the answers are already given: equal to 0 volt, more than 2 volt, equal to 2 volt, less than 2 volt, and the answer is less than 2 volt. Okay, this is another question that we have to solve while in examination hall, because this is also already very easy one. So another question I will take here. One last one from this PDF. This is the question, and this question is from MOS amplifier, and the question is: consider the circuit shown with an ideal long channel N MOSFET enhancement mode. Substrate is connected to the source. Okay, source and substrate are connected to each other. There is no body effect. Okay, yes, definitely we will share. The transistor is appropriately biased in the saturation region with VGG and VDD such that it acts as a linear amplifier. Vi is the small signal AC input, so it is acting as a linear amplifier. Already we know that the amplifier is linearly working, and this is just a question in which we have to use the small signal equivalent diagram of this particular question. So this is a small signal voltage that has been applied here. So I just write here, this is a small signal voltage, and AC input voltage VA and VB. So here we are having VA, here we are having VB. So VA and VB, we have to find out the ratio of these two, and that ratio has to be rounded off to 1 decimal places. So that means we have to find out the voltage. So I just draw the small signal model here. So what will be the small, we just write here signal and model of this particular circuit. So already we know that in a MOSFET, if you draw the small signal model, then we have to take the source here, and this two has been open circuited because the input resistance is very high, and we have just to connect a source here, and that source is grounded. Because this is the AC equivalent model, so this DC will be equal to 0. Okay, so here we have written this is Vi. Next is, what is this terminal? This terminal is gate terminal. The potential between these two is nothing but VGS. Okay, and at the output we have a dependent current source, that's why it is acting as an amplifier. So I just write here this is GM VGS, because already we have solved this one, how to get this part in your theory part. And now at this condition, this is the drain terminal, and at the drain terminal, if you observe here, okay, at the drain terminal, this is the drain terminal, this is gate terminal, this is source terminal, and in this particular diagram, this is the source terminal. After this source terminal, we have one 2K of resistor. So I just draw here and grounded this one. This is the 2K resistor. And at this drain terminal, we have VDD. Since it is the AC model, VDD is taken as 0. And this 4K is drawn here. And the other terminal of this 4K will become 0. So that is the 4K resistor. So this is the equivalent model. And we have to find out what is VA and VB. So from this particular question, VA is taken from the drain terminal. So here we are having VA. and VB is taken from the source terminal. This is the source terminal, and I just write here this is VB. So that means VB is the potential difference between these two terminals. So if we are having current, GM VGS is the current, so here we are having plus minus. In this particular circuit, since this is open circuited, what will be the current? Current will be GM VGS. Yes, current will be GM VGS. And here we are having, since current is in this direction, so we can write this is plus minus. And what will be the current? Again the current is GM VGS. GM VGS will be the current. So this is the current which is flowing in this circuit. So if you want to find out what is VA, VA means the potential difference between this particular point and ground, which is taken as, okay, so the current direction, if it is in this direction, so we can write here that VA is equal to minus of, this is GM VGS into the resistance value, that is equal to 4K. And what is VB? This is equal to, it is in the same direction, plus minus, so I will take this is plus sign. This is GM VGS, and this is multiplied by 2K. If you take the ratio of these two, then we can write the answer will be minus of 2. So this answer, so we can write the answer will be, that is VA by VB is equal to minus 2 volt, and that will be the correct answer. So if you did in this way, then definitely the answer will be the correct one. And if you done the other way, then we have to get the same answer whether you are doing in one way or other way. So this is all about today's session. I just said you that we have some limited number of questions that I have solved in this particular. So whenever I will get again questions, I will definitely give you the answer. These are all memory based questions. So thank you, and I hope that you all have done well in the examination. Meet you again, and take care, and bye bye.